every week is very different, and I think it's a function of where the fire is burning. Our customers actually tend to do that. They come to us for assessments and then they stick around even for innovation and other stuff. Amazon, obviously, that's where I learned real engineering learnings from there. There was in fact, I should call that one of the days I happened to almost bring down Amazon retail. Less than 4 years into my job. But I was like running a team at Amazon, and they're like 2-3 continents you're dealing with. And the thing is, with technology, I mean, if you read through the documentation, if you've read a book, you kind of know this is roughly 90% is figured out. With people, every day there's a moving goalpost, right? Software wants to be simple. The software wants to be clean. Truth be told, even now, I think about a good 60 to 70% of developer hiring is all DS algo based, at least at the entry level. People want AI skills, but now I think AI has reached a point where everything in AI is also become SaaS. Try and go a step beyond and actually pick up some real life problems and solve them. It helps you build a builder mindset, right? Which is solving problems at a slightly higher abstraction than just writing DS algo.
Hey, welcome to yet another episode of SCALER Pod. And today we have with us Vishwastam, who is the CTO of HackerEarth. First of all, thanks for taking out time and coming here. So yeah, I'll get started with my favorite questions is I ask different CTOs about like how does their work week look like. So I'll start with that with you as well. Like currently at the stage that HackerEarth is in, so and with your size of your team, how does your work week look like?
Thank you, first of all, for having me over here. And thank you, Arnav, and thank you, the Scaler team. Work week, I think every week is very different. And I think it's a function of where the fire is burning. And you kind of go and douse the fire. But more literally, I think it's picking your battles every day, every week. So my calendar is kind of filled with different set of agenda items. Roughly about say 20 to 30% of that is pretty engineering focused, which is talking to folks around what are some of the initiatives that are being taken up by the team. What are some of the maybe issues that customers might have faced in the last 1 week or so? How do we get around those? About 10 to 20% of my work week would be say around thinking about and talking to different stakeholders and coming up with ideas around what we can do in the coming days. The rest of it is actually a lot of it, in fact, is on the leadership side. So working with a bunch of leaders who are non-engineering stakeholders of mine and kind of figuring out strategic stuff and helping them out at times, maybe diving deep into their own functions at times and trying to help them out from a fresh perspective and those kind of things. So yeah, I would say that's how the mix looks like. The intent is always to try and pull back from all of that and focus more on the engineering. Sometimes it's possible, sometimes it's not, but yeah, that's...
Got it. So just to quickly go along with the flow on that discussion, what are the top things that HackerEarth is working on these days?
Yeah, so we've essentially been an assessment platform, right, for a long time now. HackerEarth, maybe if I go back in time, even before I joined, I've been with HackerEarth for 5.5 years now, and I think the company is about 10-11 years now.
Yeah.
So I think it started as a pure play indie sort of a project, from a college dorm and stuff, and it was built around the developer community. Very simple idea, help people land opportunities, right? So that kind of has stuck. It's just that from a community and developer focused approach, we've kind of moved more and more towards the enterprise and B2B over a period of time, because you have to make money somehow. So the community side of it is still there, and we still put out content. We still put out interesting coding challenges and things like that for our community of developers, and that remains free for them. But over say last 8 years or so, I would say the focus has been on building the B2B, the enterprise side of it. So we've been building assessments, and we've reached a stage where the product is not just very deep but also very wide. And every time we talk to a new customer, I'm surprised at how they're able to come up with even more asks, but they
Right.
do. So that's just the nature of the beast. So we
Right.
continuously work on that. Beyond that, we also have a bunch of things going on in the innovation space. So we have a hackathon platform,
Yeah.
which a lot of our customers tend to use. And every year we'll get some folk coming to us for, say, hey, can you host a web3 hackathon for us? Can you do a, let's say, AI hackathon? And sometimes these are public events, sometimes these are also private ones. So
Right.
bigger organizations coming to HackerEarth and saying, hey, I have, let's say, 2000 people on my roles, and can you help us sort of drive this innovation within my organization, right? So a lot of our customers actually tend to do that. They come to us for assessments, and then they stick around even for innovation and other stuff. So that is sort of adjacency that we have. We've recently also started working on a separate tech interviewing product called Face Code. So this
Oh,
is
nice.
so this is essentially, you have your video conferencing, and then along with that we threw the IDE part in.
Okay.
And
Full stack.
yeah, so you basically ask the candidates live coding questions, and or even SQL or whatever else you want. And you can have a panel of interviewers or a single interviewer and a candidate, and a bunch of rich features being added to it every few months, every quarter. So I think that's one space which is developing really
Right.
fast. I think a lot of platforms do exist for this as well, but it's a space where, at least in India, there aren't many players as of now. So we are very looking at it very closely and trying to see if we can make an impact. Not a lot of enterprises are actually very keen on doing this in the first place, where they're like, hey, you know what, we're using Zoom, and what's a big deal? I mean, we can have our interviews
Yeah.
there. Or we can ask the candidate to write, explain the code, and or maybe do something else. And we're like, you could do that, but it's not really a rich experience that you would want during an interview. So some companies do buy that. Some companies are still sort of averse to doing that. But I think we are sort of pushing ahead anyway. So that's one space which is kind of developing fast. The other is, and I was talking to Simran earlier, and the L&D upskilling sort of
Right.
space. So this is coming more from enterprises, where enterprises are like, I have 20,000 employees, and these are mostly services organizations, and they're like, every time I get a new project from my customer, they're asking us, how many employees do you have who are skilled in XYZ skills?
Right.
And these guys don't have an answer. Like,
Right.
they literally don't know, right? That's the answer. So they scamper around, do something, roll out some survey forms and this and that, and they're like, okay, we got some survey results, looks like 500 people in our organization know Java, and maybe 1200 odd know Python, or somebody else knows AI. But this is all like self-declared sort of a
Self-declared data.
thing.
Yeah.
Very, very voluntary sort of a thing. And that creates a challenge, because the moment you're trying to deploy those people onto those client projects, it becomes an issue, because they have to really know those
Correct.
technologies. So I think that's one space which is developing fast. We've sort of come up with an adjacency around that, and we're trying to say, okay, fair enough, if 500 employees in your organizations raise their hands and say, I know Java and I know this and that. So you roll this out
Yeah.
and see, right, what happens, right? So it's again like an assessment, but more from an upskilling angle. So the customer persona, the user persona is slightly different,
Right.
because these are not guys looking for jobs, right? These are folks who already have jobs,
Correct.
and then
Correct.
you're asking them to take a test.
So
So
that motivation, the key motivation of the job thing is not there.
not
You
there.
to
So
figure
that
something
becomes,
out. Yeah.
yeah, so it's a software element, so you have to kind of cater to that within the product somehow. You have to create those nudges and pushes where people can sort of get to it. And but yeah, that's another space which is kind of under development, and we are seeing very keen interest, like I said, from some of these consultancies, as well as from IT firms as well. Then of course there is this whole AI thing which is going on. We can
I
talk
have a
about
lot
it,
of
but
questions on that. Of course, of course. Yes,
yeah, yeah.
yes, yes.
So, but yeah, largely this is these are the
Sounds good.
trends.
Sounds good. So I'll come into like those specific challenges as well. I have some questions on that, but
Yeah.
before that, I'd love to know a little bit more about Wish than about
Hmm,
HackerEarth. So,
hmm.
if you could tell me a little bit about your journey in tech so far.
Yeah, yeah,
Like from the college days till now, like how it has been, what all places you've been to, what kind of things you've learned there.
yeah, yeah. So I went to Triple IT Allahabad.
Yeah,
That's where I did my BTech. And funny thing is, it was still a relatively new place. New college. I think they had set it up in '99 or something. A few years later, I joined. So the campus was still very new, very fresh energies and whatnot, and a lot of things were not in place. But we were lucky to have some of the best infrastructure, in terms of the labs and stuff,
hmm.
and folks who probably would talk to other friends of theirs from IITs or elsewhere. They would be very, very proud of what we had, these swanky new labs and whatnot.
Yeah,
But the other side of it was also that some of our seniors would be like, you'll have to work really, really hard. And you're like, okay, what exactly do we have to work hard on? And they're like, you'll have to work hard to fail here, because nobody fails, nobody gets an F. You'll have to work very hard. So that's the kind of culture. But one thing good about it was, from the very beginning, there was a strong cult around competitive programming and
right.
focusing on DS algo, like from the first year, second year onwards. So a lot of our folks, I think that culture probably still is there. A lot of folks were into that. I was not personally very sort of inclined towards that, but it sort of plays,
Yeah,
and
yeah.
you kind of get influenced by that. So uh, you know spent some time learning these DS algo and stuff, and just the environment was such that these are the core things, and we knew it from like first year that if you do DS algo, you'll probably crack something,
Yeah.
and you'll do good. The rest of it was just ignored, right? So somebody teaching database, somebody teaching OS, we never took it seriously, and like, okay, you just have to pass anyway, you'll get past. So yeah, that's college largely. And so third year I kind of interned with Amazon, and I think that was the first time Amazon came to our college for hiring interns. That's where the professional kind of journey started. And yeah, so I think Amazon, obviously that's where I learned real engineering. Colleges back then, at least, you didn't even know that you had to check in code, for instance, right?
Yeah.
Talking like 2005, 4, 5, 6, people were just creating projects. So somebody was learning Java, so they said, okay, let me put together a Java beans project. Somebody
Yeah.
said, okay, let me do maybe a JavaScript thing, but very, very vanilla sort of things. But because people were more focused on the competitive programming side of things, they knew that this is the one that
Mhm.
is going to make or break. I don't know how, but somehow that trend has still survived. Even now, that is the case. So Amazon,
Back then it used to be, I guess, what, top coder or something.
yeah, top coder, correct.
Top
Top
coder, right?
coder. We used to have India's best, coder in our college. He was a senior, humble fool. He actually,
Humble Fool,
unfortunately,
obviously, yeah.
yeah,
Yeah. Famous
passed
guy.
away. So,
Yeah.
but yeah, I think that's how we got into it. And then Amazon happened, and I was actually lucky to crack Amazon, to be honest. Right? Yeah, I mean, to be honest, right? I think what happened was nobody was sure if Amazon was gonna like interview, and they were also very new to India back then, 2006. I think just been a couple of years since they had set up operations, and I think we had some holidays or some such thing. Most of the people went back, so whoever was in campus, they kind of interviewed, and I got lucky there. Some 20, 30 odd folks were there. So anyway, so that's how internship happened, and that's where rubber met the road. We kind of started our boss. You have to check in the code.
Yeah.
That's the first time somebody told us, whatever you write has to be checked in, because there's no concept of GitHub. We were not aware of all of those things back then, right? So and GitHub also, I think Amazon was using SVN back then. So
Yeah, I mean, I think
so
it's
so
post 2010 when major companies started moving to Git.
moving to
Yeah,
Git,
so
yeah, yeah.
yeah, very SVN perforce and all of that
Correct,
over
correct.
there.
Yeah. So we were using a combination of SVN and Perforce. So again, I mean, moving to Amazon, very, very interesting days. I think Amazon India as a whole was probably 20 people. right?
Nice.
And today is probably, I don't know, 20,000,
Yeah.
15,000, whatever. But very, very high talent density group, very high. I mean, the moment you set a foot in that office, you were like, "Was I don't know anything."
Yeah.
So these were guys like Sachin Bansal, Binny Bansal, all of these guys were part of that gang, and from day one, nobody actually, as part of the onboarding and all, nobody actually taught us, how to write good code. Or actually, good code is probably still okay, but nobody actually taught us, how to check in your code, or how to, check out the code, the basics,
Yeah.
which you get, how to set up your desktop and all that. So all of that you were expected to sort of, figure out on your own. The things that they would actually, expose us to was like, POA talk. So we used to have principles of Amazon talks over there, right? And so they would give us a bunch of videos of talks, or they would themselves present something. And they, day one you're learning about consistent hashing, and day two you're talking about distributed transactions, and day three so it was like a complete overload, right?
Yeah.
So, but it was very, very fun times. I remember my first, task at Amazon was to actually do an SDK on a set of APIs, right? So these were payments APIs. And this is the time when there was no term called fintech, right? We were
Right.
doing fintech, but nobody used to call it fintech. It was like payments, right?
Yeah.
It's called online payments. So
Yeah.
that's what you're like, okay, fine, online payments. We'll do. India had no concept of online payments back then,
Yeah.
obviously. So these were a bunch of APIs, that SOAP APIs mostly.
Yeah.
And we were supposed to write SDKs which third-party e-commerce websites could use to sort of integrate with Amazon's payments backend, right? So anybody who's running their own e-commerce website could use Amazon's payment infrastructure to
Got it.
sort of process their payments. That was the intent. So I said, okay, I'll write the SDK, understood what goes into writing an SDK, what is a API, what is SOAP, all of that was like taken for granted. I mean, nobody goes on that. You Google it out. And back then, I think Google also was like very, very, 2006 was not
Yeah,
like very heavy.
but
Yeah. So
Google mailing list, I think that used to be a better source than Stack Overflow
correct,
also, right?
correct, correct.
Google
Stack
Groups.
Overflow, I don't recall actually us using Stack Overflow back then. Maybe it was there. I can't recall now. So yeah. But then the real thing happened, and they were like, "Oh, you have to write this SDK in Ruby." And I was like, "Boss, what are you saying? I've never really heard this name." So yeah, Ruby, and I was the only one actually who was supposed to do this SDK in Ruby, and the rest of the organization was running. I mean, doing Java, right? So nobody around me anyway knew anything about Ruby. So I was like, okay, one more thing to learn. So fine, I like, let's do this. And I go to Google and type out Ruby documentation. 99% of the results out of maybe 2 or 3 pages that I got were in Japanese. So I was like, okay, now what do we do? Because there is nothing on Google which is in English. Very, very few,
Yeah.
blogs back then which were. I think Twitter was using Ruby back then. They had just started out, but nobody knew Twitter in like
Yeah, correct.
2006 and all. So again, it was picking up. People knew that
I
this
think
is a
GitHub
language.
itself was in Ruby, but I think GitHub also nobody knew then.
Nobody knew. Yeah. So we didn't have any popular platforms.
It's all
We didn't.
PHP world then, right?
Yeah, PHP, correct. PHP, or you had these Java platforms mostly. So it was a choice, really. I mean, I learned to read code, or I learned to read Japanese. So I was like, okay, let's read code because code is written in whatever language, Ruby. So they were using at least English
Yeah.
stuff. So that's how my kind of journey started. And so I started writing code in Ruby. Learned about gems, how to do package management, all of
Yeah.
that, dependencies. Encountered a lot of bugs.
Apple used to use Ruby back then a lot, though.
Probably. Yeah,
So-
but see, most of these organizations, even Amazon for that matter, they are not very open source friendly.
Correct. Yeah, they don't publish much.
Yeah,
I mean,
so they don't publish
these
much.
days they still do a bit. I mean, back then, not at all.
Yeah, they don't talk about it. So we were very sort of secluded in that sense. We would not, we would obviously use open source, but nobody was, sort of pushing anything back. Mostly leeches. So that's how that journey started. So that was a 2-month intern. I tried to somehow put together something in Ruby, and then went back to college. And 6 months later, I had a 6-month internship with Amazon, and they called me back, and I was like, okay, now must be something really mainstream that I get to do. And like, guess what? Again, I have to pick up the same SDK because nobody touched it in the 6 months. So I was like, did you guys not work for the last 6 months? Like, no, everybody worked on something else, and your stuff was just left like that because nobody knew Ruby. They don't care. So again, Ruby started for some time, but then after that, I kind of moved towards the backend side of things, and then started developing APIs for payments. So payments was essentially what I was doing, and for my entire duration at Amazon for about 6.5, 7 years that I was there. And this was again APIs for third-party customers. So this would mean transferring money from A to B, or doing refunds or settlements, or all of those things, async workflows, notifications, all of that. So that was a time we learned a lot about again things like distributed systems, because okay, so this is very interesting. In 2000, up until I think 2003, Amazon was a monolith largely, right? And it's very hard to believe that something like Amazon could have been a monolith, but everything starts like that, right? So we were kind of sat down and told, what.
But it was mainly like the e-commerce site, right? I mean, AWS had not really picked up.
Yeah,
like that.
AWS was a separate thing altogether.
Separate,
yeah. So that started being an API from the day one, but the e-commerce site was actually running as a monolith up until 2003. So we were actually told to go through all of those things where we've seen outages and things like that historically, to sort of avoid those mistakes and to learn from those mistakes. Maybe I can touch upon a couple of them, very, very interesting ones. And I think that's how probably this whole service oriented architecture and the move towards that kind of started at Amazon. So I think one of these events, if I remember correctly, was so the code was essentially a C++ binary, right? A single binary, Amazon retail, right? And it was basically running on a SQL database, one database. Obviously the web servers, you could spawn whatever numbers, and there's a single database. And the thing was that this database obviously has its own capacity limit, so it would take, say, maximum up to 500 odd concurrent connections and whatnot. And so this was running fine, I think. And the web applications was designed in a manner that if something goes wrong or there's an error in the web application, all you do is just restart. Right, restart on it. So there's some nanny process which is running. Nanny is mostly like sidecar, what you call sidecar today, right? It's like we used to call that nanny. So there's a nanny process, and that will basically tell you to restart, and it will take care of the restart, and then you establish your connection again and you keep going, right? So fairly straightforward, right? Everybody is happy making money.
Like HTML is like generated from C++ code.
No, it was front end.
Front end is PHP.
Yeah. Front end is PHP, and this is C++.
CGI bin.
Yeah, CGI. Correct. Very, very vanilla, right? And then what happens is one fine day, you have.
This is interesting though that back then PHP used to be called front end.
Front end, yeah, absolutely.
I mean, now there is a further bifurcation.
Correct.
In that sense, like, I mean, somebody who has learned web development in the last 4 or 5 years to tell that your web server is actually used to be called front end back in the day. But every time I talk with somebody who has been working in tech for 20 years, they say that whatever you call your Express.js and all you call backend, and React you call front end. Like there was
no way you could have done front end.
You call your web server as the front end back
front end, yeah, correct. So we were like, okay, so this is going on like happily. Maybe they were running 50, 100 odd web servers, whatever. One fine day, this one of the web servers out of the entire fleet has this issue, and we are probably running close to peak load back then, and one of the web servers is basically having some issues right now. I don't know whether it is a hardware thing or a software thing, but basically the idea is to just restart it automatically and everything works fine. Now this guy restarts. What happens is the moment it comes back up, it tries to establish a connection to the database, right? Or multiple connections in the database. Now database is already running hot at that time, right? So this guy is like, okay, you want, let's say 5 new connections or 10 new connections, whatever. It will take some time for me to actually do that, because it's ultimately memory or a CPU thing, right? So it's going to take a file descriptor to kind of do that, establish that connection. So database tries to do that. While it is trying to do that, its latency obviously increases.
Yeah.
So the query engine is running slow, and you're responding slowly to the other web servers, which are otherwise running fine. Because it starts responding slowly to some of the other web servers,
they restart as well.
So they restart, and then obviously the whole thing goes for a toss.
Yeah.
So this is basically a what you used to call a death spiral, right?
Yeah.
So everything goes into a negative spiral, and everything basically starts restarting on its own, right? So this was one of the things that, and this coupled with the fact that that binary which we're talking about used to take about 10 hours to compile.
The C++ binary.
The C++ binary used to take 10 hours to compile. So any change that you had to push, you you need that much time. So, and this is before I joined. I'll tell you the time when I joined. So this is before I joined, and that kind of would piss off the leadership. It's like, how is it possible that we are running the biggest e-commerce store in the world and we're taking 10 hours to sort of compile this code and whatnot? That's where this entire move towards having a service-oriented architecture and distributing the entire thing actually started, and came from the very top. Jeff saying that was no monoliths, nothing like that. You have to distribute into various APIs and services and everybody, and that's where your Conway's law kind of hits home, and they're like, okay, if you do that, you'll have to have different teams, and that's where the two pizza teams kind of in Amazon came about. Right, so it was all sort of trickled down from that. Right, so that's how they start looking at APIs as the first class thing within Amazon. So since then, everybody has been doing APIs pretty much, right? And the other thing that they did was obviously chose Java as the primary language post that. So that gave us a lot of lessons. Plus, then there was another incident where we learned again a lot about how some of the distributed systems can have issues. So I don't know if you remember, there's this movie Hulk.
Yeah.
I think again 2003 or 4, sometime around that, and this movie became a big hit, and there was this toy Hulk hands or gloves, right? So people would order those, right? And they're very, very popular.
Yeah.
And I'm telling you this because this is something that we were coached on, right? These were our first few lessons at Amazon, right? I mean, of course, we were writing code, but most of the other time we were going through all these classes sort of thing.
Yeah.
So Hulk hands, very popular. People are ordering from Amazon and whatnot. One guy, I think he was probably a studio executive in LA or somewhere, and he's like, he ordered Hulk hands in like 500 quantity. So he went to the Amazon.com, added 500 quantity, and like place order, done, right? So he's happily sitting expecting 500 Hulk hands to show up, right? And we take the order, give him the order ID, and like everything is normal till then. At some point, it goes to the warehouse team, and they get notified that you have to ship like 500 of these, and order any order at Amazon. I don't know if they've changed now, but used to be like a document, sort of an entity, multiple fields over there. It's like a document in the backend. And that document was basically shared across multiple services. So we had distributed everything back then, right? So these guys are, okay, 500 Hulk hands. Now the problem was Hulk hands used to be like this big, right? And that a pair. So at max, you can have like one pair being shipped in a box. Now that meant you have to have 500 different shipments.
Yeah.
And what that meant was that every time you shipped a pair of gloves, you would update the same order entity,
order ID,
and basically insert a new shipment there. Yeah. So it's like a nested block of in the document saying that this is the shipment ID and this is the shipment detail and blah blah blah, barcode, whatever else, those details, and you basically update the order. Now the moment you update that document, it gets sort of populated into multiple other services. And so they start shipping. So one shipment, two shipments, by the time it gets to like 20-30 different shipments, the order is becoming bulkier and bulkier and bulkier, and that same document is basically essentially DDoSing the entire system in the back end. right? So it took down Amazon.com one order, 500 quantities, Hulk hands. If it was any other thing, it would have probably not mattered, but
Because
because it
the
was
shipment number
the
would have not
shipment
have been a
size
problem.
was too big. And so yeah, so that basically kind of helped us learn about how distributed systems can also go bad at times. So that was that. Then I think a lot of issues we used to have, a lot of new learnings around distributed logging and stuff, because see, the moment you take a natively monolith thing and you sort of break it down, there are n number of things that just open up, right?
Yeah.
You're probably solving one problem and then suddenly you're opening up doors for 10 other issues. So I remember this was the time when I was there. We had a very interesting issue come up. um, so this entire because it's payment, so you have to have very tight logging, and it's a distributed transaction, so you have to have logging across all multiple services, and you have to tie everything up and kind of keep it in one place. So because you have to at times reconcile what happened and whatnot, it's not something that you can lose at any point, or very high SLA guarantees
Yeah.
and whatnot. So this was, I think, yeah, if I remember correctly, there was some issue with one of the C++ libraries, or yeah, I think it was one of the OS libraries, APL core or something. And in that library, there was a bug, right?
Okay.
And the bug was such that you will have you can have at max. I think the file size limitation was around 32-bit signed integer, right?
Huh.
Okay, which is fine. So we obviously didn't own the library, but we were like, we can work around with this. So file size 32-bit signed integer means you can have the maximum log file size as 2 GB.
Yeah.
So like the moment it is reaching around 2 GB, we'll cut it off and we'll roll
Make a
on to
new
the next one, and everything works fine. So that was working for quite some time, right? And every 2 hours, basically a new file would get created. We start appending logs there, and this is um, you know at the end of, I think, roughly about 2 hours it would take to fill up 2 GB a log file back then. And every 2 hours we'll have this log puller sort of a tool which would
We'll
come
take
in and
the
will
old
take
logs.
and yank it to some other place. So everything is running fine. Then some guy basically joins the team which owned the lock puller
Okay.
tool, right? And what they decide is one day that what, lock puller needs to be made a little bit more intelligent and whatnot. So they what they did was they changed the lock puller in a manner that it would add a few lines at the end of the log file to somehow say that this is the end of log for EOF sort of a thing, and maybe append something there, maybe 2-3 lines additional, right? Whatever. So they made that change, obviously not aware of the fact that it's a
It's like
hard
2
cutoff,
GB.
right? And all the systems are basically writing the same, using the same library, APL Go library, and writing the same set of files. They deployed this, and from the moment it was deployed, 2 hours, everything was fine, roughly 2 hours. And after 2 hours, when the actual log puller thing came about, one after the other, web servers are randomly going down. So what was happening? It took a lot of time to actually debug, because the application was running absolutely fine. There was no CPU memory issues there. Then somebody said, you know what? It's the IO which is kind of hitting us. A lot of these web servers are busy doing a lot of IO. And then we were looking at application. There was nothing happening on the application side, which was IO intensive. Then we look at this log puller, and that's when we figured out that the log puller is basically trying to write something. And while it is trying to do that, because the file size limit is already crossed, so what happens is that you end up writing to standard error, SCDERR, right? And that write actually happens one character at a time.
Oh, that's a slow write. Yeah.
Yeah. So because it's
Well, it's
writing,
output pipeline. Yeah.
yeah. So it's writing one character at a time on, and it starts happening like every 2 hours. So all your web servers are basically just doing IO, and it's just going down one after the other. So I think Amazon.com was probably down for just 2 to 3 hours, 4 hours probably. I can't recall, like multi-hour downtime. So fun days.
Yeah.
But these were essentially, some of the key learnings. Otherwise, we were just, writing simple code, and it was tough to actually fail. Right? It was not very easy to fail in the guardrails that we were, operating within. The funny thing was, uh, we were based in India, right? 20-25 odd people. Most of the code base and everything was in Seattle, US East 1 data center. So if we had to do a code checkout, it used to take probably an hour or so to just check out the code, right? Internet speeds back then, I think probably a few MBs at max, right? And we used to be very proud of it. Right? We have 1 Mbps leased line or whatever, and like so that time, few hours to check out the code, and if you had to check in, then again it's a similar
Do
amount of
full
time.
trunk checkout check-in,
Full
right?
trunk, yeah. And then you also, if you had to build, then you had to download the sort of dependencies locally, and have a local repository of dependencies and whatnot. So that could take 10-12 hours.
Hmm.
So sometimes you would make some code changes and start a build and go home, right? Come back the next day, and the next day you would open up your terminal and find it failed, and then you're screwed because you lost the entire day again.
Yeah.
So those were, the times, and but a lot of fun, a lot of learning, a lot of fun. We then obviously, I kept on sort of developing this backend APIs, developed a notification system where used to basically intimate these third parties that, hey, your transaction was successful or whatnot. I mean, basic stuff with payments. um, from that point, I think we launched what is called as the shopping cart for third parties.
Okay.
So Amazon has a shopping cart offering for third parties as well. You could just take a JavaScript, integrate it within your website, and basically get your
So
e-commerce
your
thing up and running
cart and your checkout happens via Amazon
via Amazon.
platform,
Correct.
and rest of your store is your own kind of
Right,
thing.
right. So functionality wise, we were developing that, and you could obviously, that meant that you could reuse your Amazon address and Amazon wallet and whatnot. So
Yeah.
so we were kind of doing the same thing but outside Amazon, the
Right.
checkout and the payments. So again, interesting set of learnings from there. There was in fact, I should call that one of the days I happened to almost bring down Amazon retail. So that also happened. So we were writing these APIs, and somebody suggested, what, we are going big, because we were growing very fast in US, and at that, I think US was the only market that we were present in back then. And so we were like, okay, so we'll have to do some performance testing and whatnot. So I said, okay. I mean, we figured out JMeter or whatever
Yeah.
else can be used to sort of spawn n number of threads, and you can set up some ramp up time, and it will launch those many threads, and all good, and you can test it out. So the only hard part was that our set of APIs were dependent on like 10-20 other systems in the backend, which were probably retail systems, right? Because that infrastructure is common, right? So creating an order, so even if we were doing pure payments in the backend, it would still create an order, and the payment would happen underneath that order umbrella, because that's just how the systems were written back then. So there are a lot of dependency, a lot of upstream systems that we were dependent on, systems that would talk to Visa, MasterCard, like, the last mile payment processors, the fraud checks, transaction risk, all of those things were running real time. And I remember, we basically used to have a form that I filled up, and I said, okay, I'm going to test this API, or this set of APIs at about 100 transactions per second or whatever. And so the process was that you have to talk to all your upstream services, get a sign off from them, because they have to support this. So I went to all of them, and they had like, okay, that's fine, 100 transactions per second, we will give you a different endpoint because we can't let you use the production one. So they all gave me the testing endpoints
Testing
that
endpoint.
there, and they provisioned whatever infra was required to set this up. And of course, we were sitting in our little cocoon in Bangalore, and the rest of the teams were in Seattle. That
Yeah.
also played a part everywhere. So we did this, and I'm running this like maybe 2 p.m. my time, Seattle, probably 3:30 or
Yeah.
something, at early morning. and suddenly there is a SEV1. SEV1 is basically like this high severity
High
issue,
severity.
right? And so at Amazon, we used to have this segregation that if a tier one service has an issue, then it can cause a SEV1. We were not tier one because we were not directly dealing with retail, right? We were doing something else. So we were tier two. So I was like, okay, must be something else because we are tier two. There's a tier one issue going on. Then half an hour later, somebody rings up our office and is like, boss, you guys are doing something. You must stop. And that guy is up at night like 3:30 a.m. or something, and he's debugging something. He's like, you guys are just hammering our systems. So that's when somebody tells me that, what, there's something going on, can you just stop whatever you are doing, right? I'm like, okay, I'll stop whatever I'm doing. And things are fine. Like, it took 1 hour, 1.5 hours. Luckily nothing went down, but it started browning out, right? The retail system was browning out. It was late night, so it didn't really impact that much. But things were running very, very slow on the retail end. So that's when that guy basically got on a conf call, got my manager's manager, VP. Everybody is like, from here, that side it's only one single guy. He's like, giving us left, right, and center, like, what are you doing? How can you do this? Like, but I took an approval from XYZ. These are all our upstream services. So turns out our upstream services also had some upstream guys, and those guys didn't inform the other set, and they were hammering the production.
Okay.
So that's how it had like a ripple effect.
So you were using the test endpoints, but your upstream services were still on production.
Yeah. So one of those guys was using production, and we basically ended up almost bringing down retail. So yeah, but yeah, those were sort of not really high points, but those are things that stick, right?
Yeah.
Rest of it is right, plain vanilla Java code most of the times. So that was Amazon. And then I think we launched it in US. US was doing really well, and of course we had a brand name, so a lot of trust and everything. Then I joined a team. Different team was carved out to do the same, launch the same checkout and shopping cart functionality for Europe. So we picked UK and Germany as the geographies where we had to do this. This was about a 15-member team, and Amazon India by then had grown probably 200 odd. I think this is 2009 or something. So we started building for that, and actually it was pretty 2010 probably, yeah. So just 3.5 years of being there at Amazon. That's when and we were kind of this was a war room sort of a situation where we had to launch in Europe in like next 3 to 4 months, and people are just rallying behind you. And the problem was that most of our product guys would sit still out of US, and the dev team is here, and the rest of the business folks were actually in Europe.
So 3 different time zones to work.
3 different time zones to work. Europe was generally easier to work with. Obviously, US was slightly difficult, but getting everybody on a call was almost always very difficult. So this is how you're sort of working and working against a tough timeline. Amazon culturally always has been like very, very breakneck speed. I mean, there are pros and cons, but it is what it is, right? It was not never like you could just sit back and relax, never, right? So you just got used to it. You start enjoying it, or you just move out, right? So we were in that phase, shipping out code every day, and then suddenly our manager so we had a non-two pizza team. We had like 15-member team or so. Generally used to be around 8 to 10 max. We had a 15-member team because we were supposed to ship something very, very big and very crucial and whatnot. So my manager basically decides to move on at that point when we're like 2-3 months away from the release, and we are like now what, headless chickens, right? Literally. So that's a key moment, because that's when we had to sort of do a in engineering terms like a master selection sort of a thing. So somebody had to be made the lead or the manager or whatever, right? And there was this adjacent team where they were basically running the US product back then, and the manager from there was like, why don't you pick it up? And I was like, I have no idea like how this is gonna work, because I've never really led any team, and it's still very, very new. I'm just writing code here. I'm just doing what I'm told to do. How can I run this? And especially a team which is like 16-member team, generally don't have that big teams. And then there are folks who are obviously senior to me, right? So not happening. Then he obviously goes back to Seattle folks, talks to the leadership, and somehow whatever they discussed, but they made me the manager. Right?
Okay.
And they're like, 2 months, 3 months down the line, you have to release this. This is your team. You are the manager from today. You go talk to everyone and figure this out. So that's my move into people management.
Right.
Happened very early and very unnaturally by an accident, but that's how it happened.
Right.
So everything changed from that day onwards, right? Maybe I was still writing code 50-60% of the time, and I was still like I said, less than 4 years into my job. But I was like running a team at Amazon, and they're like 2-3 continents you're dealing with. So obviously the natural side effect of that was that we started getting escalations left, right, and center. US product managers are writing to my VP saying that, hey, this guy is not good enough. Can you get somebody else? And then business folks in Europe who are like, business development and all of those folks who are supposed to onboard these customers and partners, third parties onto our platform, they are also sort of writing to me and writing to our director VP saying that, where are things, they're not on track and stuff. So a lot of firefighting and
Right.
and getting a lot of flack. So it's like
And how difficult is to do like the mindset shift, like, because
it's a trial by fire. I mean,
Yeah.
you have to get into it, and you get burnt, and you get hit, and again get up because you don't have an option.
there's a lot of stuff which is like not writing code which you have to do, and sometimes you
Absolutely.
want to excuse yourself and just go back
Absolutely.
to writing
So
code.
you want to
right,
go
and
back into
listening.
that cocoon and just do what you're told to do, right?
That's what I have faced when I was in a similar transition. It feels like, okay,
Yeah,
like
yeah.
maybe I can write more code to solve all of these problems.
Correct.
That's something I know and I can do.
Absolutely. So I was I used to think like, that's when I realized that writing code could be so much more peaceful and just relaxing, because every morning you get up, and like I said, there were guys who were senior to me, right?
Yeah.
In the same team, and they were, I was almost like they were mentoring me, and then suddenly I'm the sort of guy who's supposed to manage them. So there were equations which were obviously, the dynamics is very, very
Yeah.
different. So getting them on board, getting them to buy into things that I'm telling them, winning their confidence. So all of those things were quite challenging. And the thing is, with technology, I mean, if you read through the documentation, if you read a book, you kind of know this is roughly 90% is figured out. With people, every day there's a moving goalpost, right? Somebody got up from the wrong side of the bed and you're dealing with it, right? Somebody had a fight at home and you're dealing with that. So you never know, right? And Java never comes back to you and asks for a raise. People are like, I helped you, and I need a raise or what. So those are very, very different things.
Yeah.
Like handling people was like, at least back then, it was the toughest thing that I could have even imagined, right? But so I had to make like multiple trips, to Luxembourg and then Seattle, and then calm nerves, and then talk to them, get schooled on a bunch of things, come back, and then talk to these guys. Happened like all of that. I think in the next 3 to 4 months, those 3 to 4 months are probably the most uphill sort of steep learning curves for me in my entire career. Technology, I was still learning, but that you could do at your own pace, because there things move a little different. People side was very, very difficult, uh, and it was an accident. It's not like you were prepping for it, right?
Yeah.
You just para dropped into something, and then
Right,
you
right.
kind of are dealing with that. So that's how that move happened. Luckily, once all the dust settled, we were actually doing pretty well, and in the first few months of launching in Germany and UK, we were running like 25-30% of our US business in the first few months. So that was pretty amazing, and people tell me that this is probably one of the most successful launches that we had back then. And so that was satisfying. But it also told me a lot that, there's a different side of technology management which you need to sort of look into, and if you want to get into that space, there are a lot of things to learn.
Yeah.
And but from that point on, I never really looked back towards a full-time development sort of a thing. As always, running teams, running charters, and because it was so successful, there were more initiatives coming my way, and people were like, can you run this, can you run that, sort of thing. But very, very interesting set of learnings. Again, obviously there were domain learnings, right? So how they do payments in US is very different from how they do it in UK and how they do it in Germany. They use something called direct debit, very, very popular, which is like a pre-approved, sort of recurring payment sort of a thing. So somebody gets approval from you to do a payment few days later or few hours later and whatnot. So that's very different from a credit card payment. Mostly US is all credit cards. So there's a lot of domain learning, and of course dealing with folks who are non-native English speakers. So there's that learning as well. I remember there used to be calls where I would sit and on this side, and there used to be folks, I think Irish folks. Irish are still okay, but probably folks from Luxembourg and folks from Berlin, and some of those folks early on, it was very hard to even make sense of what they were talking about. And then our QA folks, some of them in US, used to be from China. So I used to basically, after the calls were over, I used to write them emails, hey, can you like tell me what is happening. Some points I would not pick up, but so all lot of learning, right? And just that amount of exposure early on in the career, I think that helped a lot. So yeah, that was that. Then I had a couple of opportunities. One was to sort of go directly. We used to, at Amazon, we used to have something called accelerated growth program.
Okay.
So AGP. So basically the idea was that if you have a high potential candidate, you identify that person and basically put them through some sort of a high growth pipe and give them some very challenging stuff, and say 18 months down the line, if they are successful in completing whatever you gave them, then these candidates basically jump 2 levels at least, right, in 18 months. And so I got sort of nominated for that. And so as part of that, one of the retail organization, which was the biggest organization in Amazon, one of the VPs basically rang me up and said, why don't you come directly work with me? So the idea was that I work as a quote unquote technology advisor for him, and work next to him. And basically at that point, the growth path would have been that if you work with him, the next level could be, you work directly with Jeff B and sort of be a technical advisor with him and whatnot. So that's a very different track. It's not really a management track. You're basically like a shadow sort of a thing. Sometimes you could also think of it as a secretary or a glorified secretary kind of a thing, but it's all on the tech side. So that was one option that was presented, obviously Seattle based. And then the other was to kind of go and set up a office in Bay Area for Amazon, because Amazon back then was restricted because of the tax rules in US. So Amazon did not have to collect taxes from any Amazon buyer from any other state other than Washington, because Washington is where they had their physical presence.
Seattle.
So they were kind of not collecting taxes from anybody else, and that made them actually very, very competitive pricing wise. You could just pass on that benefit to the buyers. But that tax law actually changed in 2011, I think, sometime. And what that meant was Amazon could now have a physical presence in other places. So that's when they decided, hey, somebody needs to go to California, because that's where a lot of talent is, and go set up shop and start hiring people. So that was the other opportunity, and I kind of fell towards that. And I said, okay, let me go and set up an office and set up a team over there. Obviously, I was working with Amazon Payments, so the first team that happened to be set up there was Amazon Payments team. So like I was still in Bangalore back then in 2011, and I was making multiple trips. We were doing hiring events in Palo Alto and stuff, and I used to go and sort of talk to folks and excite them about Amazon. And finally, I think in sometime in 2012 is when I moved. We had already offered 4 or 5 folks, and they were supposed to join, so I also happened to move there. And very different set of talent pool, because the thing with the US, I realized, was that the talent pool is not just the real talent pool is not just bigger, but also very, very deep. right? So we, for instance, we could very easily hire 3 SD3s, right, or 2 SD3s in Bay Area in a matter of couple of months. Back then in Bangalore, used to have one SD3 which used to celebrate like, boss, you have one SD3, right? Now it's different, and I think the bar has also sort of diluted a little bit, I'd say. So these are guys.
And the levels have also increased internally, right? The ladder is also
Correct,
made a
yeah,
more
yeah.
granular ladder.
Correct. So I mean, I remember one of the guys I hired was a Yahoo Messenger architect. Like, he had written Yahoo Messenger code. Yahoo Messenger, I don't know whether you would have used it or
I've
not,
used it, yeah.
but yeah, Yahoo Messenger was a big deal, right?
Yeah.
In those days, and he had written a lot of code, and he was one of the
They were the first things after IRC which could handle that amount of distributed traffic.
Correct. Yeah, it was pretty good actually.
Yeah.
For that time, I think it was one of the best things out there.
They sort of beat out MSN Live and all of that.
Yeah, hands down.
Yeah.
Like avatars and all. Like,
Yeah.
first thing, those are good days. Anyway, so we hired one of those guys, and he had like 17-18 years experience. Then we hired another guy from Verizon. I think he had done a lot of good things. So it was very easy to sort of hire these folks who are very, very experienced, and they had been writing code ever since, right? They'd just written code. In India, finding that kind of talent is very tough. Culturally also, people kind of move more towards management. They prefer to do that. They like the manager tag and whatnot.
I think also there's like the Bay Area, I think the college ecosystem there, the universities where
Correct.
a lot of times people end up staying there for 3-4 years tinkering with code and all in university, and
Yeah, absolutely. No, I think these guys, I mean, one of the Yahoo guys, I think, if I remember correctly, he had written code in like uh, all sorts of chipsets that I could recall. So yeah, he had been writing code, for a long time. And then this other guy, so one was a Chinese, one was an Indian, and then we obviously hired more. Set up a team of about 12 15 folks in the next 3 to 4 months. It was very easy. Imagine that kind of talent density, hiring 15 folks in India. You'll be like going nuts. It's very difficult. But there again, there was this people challenge, because I was relatively still very, very new as a manager, as hiring folks who are like thrice my years of experience. But there it was not as difficult, because culturally people are okay with that. People are like, you do your job, I'll do my job, and we're fine. And they were obviously getting paid twice or thrice more than what I was getting paid. So it was also, and I was kind of deciding those salaries. So it's a little tricky.
I know that. I'd worked at Target for a year. I was working out of India, but I think I was lead in a team, and then there were people in my team. I think there were a couple of people in my team here who were obviously like fairly more experienced than me. I think the team was 10 people. I think I was probably second from the bottom in years of experience, and I was the lead of the team.
Correct.
But I think the 1 or 2 people in India, I think I had a lot more, I think, challenges getting to work comfortably with,
as compared to Minneapolis or somewhere else.
Yeah, and then the rest of the folks, I think the 5-6 folks from Minneapolis, and all of them were fairly more experienced than me.
Correct.
And there weren't any challenges actually there.
Correct.
So yeah,
culturally very different.
Yeah.
So so that was actually good. The challenge was to kind of be able to get work out of them, because ultimately, being the manager or the lead, I was the one who's responsible for execution.
Yeah.
Right. So some of these guys would be very finicky about about anything that they're putting in code.
Yeah.
And they're like, what, there's all kinds of code smell in this code. I need to fix I had to fix this. And I distinctly remember the Chinese guy who was there, Bing, I remember if his name correctly. He used to tell me, look, Vishy, you know what, the software wants to be simple. The software wants to be clean. And I was like, yes, I agree with you there. It was funny, but at the same time, it was very, very philosophical, talking to some of these guys. And they had so much experience that you obviously had to, listen to them. So getting them to work at a certain pace.
I think that's also a great experience when you work with a lot of such people in the team who care so much about.
Absolutely.
And it's really uphill when you don't have such people in the team who care about. Like, I mean, in saying something like, the code wants to be simple, right? You really think of the code as an alive entity, and you care about it, and
Absolutely. It's almost like it's not even a metaphor for them. It's like a living thing, and code is a living thing for them. So a lot of, so
you have to worry about the delivery time, but you never have to worry about quality actually, because
Correct.
that's something they are more caring about than you yourself are.
Absolutely. So I remember one of these guys, they came back with with some example from Amazon itself, and they're like, "Look, Vishy, this is what will happen if you don't." I was like, "What is it?" So he basically, there's a principles of Amazon talk, and they basically talk about not so clean code. So they give examples about not so clean code, and one guy goes into the Amazon.com repository and basically searches "fix me."
Yeah.
Right, and he prints it, all the results, right, and that is a time when they used to have inkjet printers, right, not like individual paper, so there's a roll, so it doesn't break, so you can actually, it's like a one big roll. So he comes with that entire roll, and he asks people to volunteer and just spread that roll out. It would not fill in that hall, it is that big. So he just searched fix me or to do. So
quite a way to make a point.
That's the way to make a point. And now how do you influence these guys, right, who have such a strong connect with quality of code and whatnot. So that was a learning, and honestly, that was the part that I really loved. And of course, you get to learn from them a lot of on the technology side anyway, like they would say, just come over and casually talk about things which you would probably not even think about. Like, they're talking about compilers in a very, very casual manner, and 2-pass and 3-pass and whatnot, and they're saying they're somehow able to relate that to the number of people. And Conway's law for us is like something we study about, and they are like, in their minds, it was so clear back then that, hey, if your team is building a 3-pass compiler, it's probably a 3-member team. Right, those kind of things. Right, or if you're doing a microservices, then probably this is how your team interactions look like. So very, very ingrained, those things, because they've been practicing the art for quite some time. So a lot of learning from those guys. So I did run that team for about, I think, 8 to 9 months or so. But after that, once things were settled, and we kind of started delivering things at a certain pace, that's when I said, I realized myself that I was probably doing the same thing that I was doing back in India, and nothing new. Right, and probably sometime in 2013 is when I decided, okay, this is enough, and I need to sort of do something else.
Right.
So that's the Amazon long story, but lot of good learnings.
Nice.
Yeah. So from there, I kind of moved back, and I joined a very small bunch of people. I think 8 to 10 member team, MoveInSync, and I
moved back as in back to India.
Back to India. Yeah, I moved.
So did you like? I mean, I understand like the work and the Amazon side of it, but did you not consider staying in the Bay Area?
No. So I honestly never wanted to settle down there. So I was very connected to the ecosystem here, in the sense that friends, family, and whatnot. Plus, I'm a big foodie, and somehow US food, never was like very inspiring for me. So I was somehow missing something or the other over there all the time. So I was like, I can't settle down here. Right. So I would, travel. Even when I was actually setting up the team, I had not actually moved till the time my team had already been hired and they were actually joining. Right. Some of them had already joined. After that, I moved. I was like, let them join, then I'll move. So it's never really keen on staying.
I mean, there for a year.
About a year, roughly. And that was never really the intent. And obviously, it's a great place. I mean, talent wise and even otherwise, I think US by far remains a place to be in if you like other things. Lifestyle is better and whatnot, but that's about it. I mean, you kind of draw a line. And I'd seen a lot of my seniors and other leaders who were kind of obviously settled there for like 10 years, 15 years, and they had families and houses. I never really wanted that in the US anyway. So for me, it was like, I will always be thinking about when to move back. Right. So anyway, let's pick something which is in India. So that's when this opportunity happened to come about. And one of the founders there was my manager earlier at Amazon. So he had joined these guys as a co-founder, MoveInSync, and
Okay.
3 co-founders, ITBHU guys. And I said, so I looked at the use case. So use case was very, very interesting. Use case was basically, now if I had to put it simply, it was like Ola and Uber for B2B, for
Okay.
enterprises.
Freight management.
No, not freight
No.
management. People, right? Moving people. So people who come to office,
Okay.
from their homes and back, and basically they use the office cab option.
Okay.
Right?
Got
So
it.
that part. Now, I had faced those challenges because I was working at Amazon India. We used to get a cab, and it was a pain in ass.
It's a big
Right?
thing in India, like
Yeah,
cabs in office are.
it's actually regulated. So it's by law, it is required that if you're working beyond a certain number of hours, then you have to, especially for female folks.
Women, yeah.
So it's required. So that's how this whole thing came about. And the use case was very interesting because I knew there were real problems, and I could create a real impact for a lot of people, right, who were using these. And back then I think startups was the hot thing, and like yeah, this is something that I must do. So I moved back and joined like a 10 member team probably. They had a couple of customers. I think Google was one of the first customers, and maybe a couple of others, but very, very small, very nascent stage thing. And at that time, I think even Ola was very small. So it was difficult to even pitch to VCs and funds and say, into 2013, 2014, to say that I'm building something which probably doesn't exist anywhere else in the world, right? Because you didn't have any examples in the US. So that pitch is out of the window, because a lot of people pitch it that way, that, hey, this is Uber for X and whatnot. At that point, there was no such story. Nobody was doing this in B2B. And because no other country had this kind of a setup, it was very unique to India. But anyway, we banged on the customer's money, and we kind of did it the hard way, and we started growing that. So a lot of very interesting challenges over there. But I think it was mostly about taking a space which is heavily unorganized, very non-transparent, very inefficient, and then uh, putting in some amount of governance through technology, and bringing in transparency, and then trying to solve real problems. So I can give you like countless examples of things where, we would basically go to an organization, a BFSI organization or a big tech company, and we'll tell them, hey, you know what, you're running an employee commute operation with say 500 odd cabs, and in reality you need probably 100, right? And that would basically shock them. And a lot of times it meant that their jobs were on the line as well, because they were responsible for running such a big operation. And in the enterprises P&L, after employee salaries, this was the biggest ticket item.
Right.
So if you told somebody that, hey, this is your biggest ticket item, second biggest ticket item, and you are wasting 80% of money here, they would be scared, they'd be shocked, and they'd be like, sorry, I'm not talking to you. Right? Because their jobs are on the line.
Correct.
They are the ones who are managing the entire thing. So it was difficult both ways. So you'd not get funds from VCs, and you'd also get customers who would basically not be very open. But of course, there were companies where you had decent folks, and that's where we started. So we first targeted, Googles and Amazons and Microsofts of the world. The people were more sorted. They like, okay, let's do this. How do you want to do this? And the moment we started looking at things, so how it used to work was, if you took an office cab, like in a non-MoveInSync era, right? You basically sat in the cab, and the cab driver would give you a paper sheet where you would write your name and sign it and put the time, right? So that's basically called the trip sheet. Right? Now imagine an organization which has say 10,000 employees. Each employee comes to office, goes back, so 2 trips for an employee, so 20,000 trips is what they're doing on paper.
Yeah, and right? They will stack them up, and the cab company will submit that whole thing for invoicing.
Right? So at the end of the month, you have like hundreds of thousands, or probably over 1 million such papers, million papers, right? And then somebody has to sit down and match and verify and ensure that all of that is correct, and then basically do the billing. So cab companies have to be paid off, then cab companies will pay the drivers, and it used to take about 3 to 4 months for them to actually clear this entire thing.
Yeah.
Right, so there was a 3 to 4 month gap for the driver to actually get paid. Right, and that's just the cycle. That's how the system was working. Right, so that was one part of it, huge part of it, which is basically inefficient. Right, you didn't have to do that, and they literally this big pile of papers is what they were sitting with. Right, the second big problem was that there is absolutely no transparency in terms of did those paper sheets actually happen on the road.
Yeah, and like if you're reconciling 3 months down the lane, it's very hard to even get it validated.
Correct. So there was no transparency. There was no way in which you could have any validation whatsoever. So there were simply hundreds and hundreds of trips which were just ghost trips.
Yeah,
Nobody
of course,
sitting in the
of
cab.
course.
Actually, the cab also is not there. You're just paying the guy.
Yeah.
Right. So that was there. And then once you're through with that, then you have the problem of trips which are actually happening, but say it's a 12-kilometer trip and that guy is charging you for 15 kilometers or 14
Of
and a
course,
half.
yeah,
You have
all
no
of
way
this.
of
Yeah.
verifying, right? There's absolutely no way. So that's where you get the Android device, put it in, and you
Yeah, of
basically
course.
start tracking it. So but again, because there was no Ola, Uber, which was mainstream back then, drivers would basically revolt. And they're like, boss, this is not happening. I'll get paid by odometer or I'll not work for you. Right. So a lot of times we used to sort of get calls from city administration in Kolkata saying that, boss, these 100 guys are blocking the highway. What have you guys done? Right, that used to happen. It was very, very interesting. So it was so real world that you could sort of feel it around you. There was that impact, right? And that was the part that actually excited me, that this is something like real life. I can actually see what is happening, instead of just writing code into GBs of repository somewhere, adding few lines.
Right.
So I think that impact was very, very interesting. So yeah, I think we started with some of these problems, and then so the other challenge was also that the customer or the user persona was very varied. So you had one side, you were dealing with the top administration, which is like finance and procurement and whatnot, the top leadership there, and facilities guys. And the other side, you had folks like drivers.
Yeah.
Right. So you were building a product which is being used across this, right? So there are language challenges with drivers and whatnot. So drivers mostly deal with these Android devices, and back then I remember we used to import Huawei Android devices from China because nobody in India was ready to supply it at bulk. So we used to get those devices, root them, and sort of put our stuff there, and then sort of run it. So everything customized, right? So it was not even like a normal phone. It would open very differently. People were like, this is not a phone.
Like
I will
a
not use
kind
it.
of phone.
Right. So that, and then there were other issues related to hey, you know what, my GPS stopped working. Now my kilometers are not getting tracked properly, so what do? I will not get paid. So these were genuine concerns, right? So we had to build some backup saying that, okay, if you don't have a GPS, I think GLONASS or some, so if we are not latched on to a proper GPS connection, then we used to fall back onto the triangulated network location. I think back then, at least at the very start, Android did not have a fuse location. Few years later, I think
2016 it came.
15, 16 probably it came up.
16 is where you had the
correct.
triangulation plus use the single API for all the things.
Correct. So before that, it was a different thing. So we had a code which basically switch between the two. If not this, then fall back to that.
Like your own fuse location.
Correct. Our own thing, right? So we used to do that. Then I think after fused, that problem was sorted because they had a fairly decent way of figuring out the location. Then we had problems like on the employee side. So these cabs have to be shared amongst the employees, right? So let's say if there is a cab which is basically supposed to pick up folks from office and drop them home, then which are those 2-3 guys who will sit in a single cab? So figuring that. So it's
traveling
more like a
salesman
routing waypoint algorithm sort of a thing. Or they have to be picked up from their homes and then they have to come to office. So which are the guys who have to be clubbed?
Traveling salesman.
Traveling salesman. So you used to think like, oh, this is traveling salesman. Actually, when you do this in real life, the constraints are very different.
Of course,
Constraints are so different. So for instance, that this office, there are 2-3 guys who probably live in the same building, but guess what? They come at different times.
The time
so
is
you can't club them, right? So similarly, there used to be
like stretches of road where like up is 10 minutes and down is 1 hour kind of things also happen.
Correct. U-turns are a big deal,
U-turns,
right? Similarly, there were constraints like if there is a woman employee
She
who's
can't be
boarding,
alone in it.
who's boarding first, then the cab guy has to first pick up a security guy
Yeah.
and then go to so there's a very roundabout way of doing that. Similarly, if the woman employee is being dropped last, then somebody has to the security guy has to be there in that cab.
Yeah.
So a lot of these constraints actually come into that algorithm. So it no more remains a traveling salesman problem. Luckily for us, and actually then what you realize is brute force is the best.
Yeah.
Right? You basically have a 2 by n by n matrix and you basically just
brute
throw
force
it.
and find the best one out of
Find
it.
the best one, because anyway you're ruling out most of the other stuff through these constraints. So that was the other interesting thing. And then of course doing this in B2B meant that there were a lot of enterprise bells and whistles that come to your SaaS platform. So initially when we started with the likes of Googles and Amazon, they didn't really care much about what you're doing with our data. They were like, okay, don't leak it and whatever. But when we started working with banks, for instance, American Express or Bank of America or whatever else, right? These were big entities and they were super finicky about the kind of data that they were sharing with us, and we needed everything. Right? We needed all the employee details. That's the first thing that we started. Right? Employee name, address, phone number, everything. Right? So all the PII that you could have owned is basically with us. Right? At least the entire HR database is
even
basically
their home address.
Home address, right?
That's
so we actually knew what route the employee is taking, what time they are getting dropped, what time they're starting back. So everything, right? And so that meant a lot of incorporating a lot of security stuff into the product. So baking in controls around ISO and all of those were required. Then there were requirements around some folks were very finicky about co-location of data. That becomes a big deal in enterprise software at the
On-prem and
moment.
stuff like that, yeah.
So they were like, even if they didn't want on-prem, they were like, you can't co-locate my data with somebody else. I need a separate database. Now, sometimes you sort of made it work with logical separation. You didn't really have a different node, but you have like multiple databases running within the same physical node. For some people, it worked, but eventually we had to actually separate out databases, which meant partitioning, sharding the data.
Actual multi-tenancy.
Right? So that was a challenge. In fact, that came as a sort of a it was almost like a war room situation, because one of the big customers that we were onboarding, this was one of the first requirements that they had, and they were not ready to budge on this. And we had, I think, 15-20 days to kind of deliver on this. Before that, everything was running on Postgres. We used to have a read replica, and everything else was basically running on a single database. And I think, if I remember correctly, Postgres did not natively have a great support for sharding back then, 2014, 2015. I think it's only 2017 they probably came up with a proper sharding support. So that was very interesting. So we had to build something on our own, right? Basically plumbing the entire sharding thing on our own. So writing code to kind of
shard by the client.
So we had to decide, actually. So we had no other option but to actually shard by the client, which was also in a way good because then the cardinality is high. Right? You could have as many shards as you want, right? But it also meant that at times you would be probably required to reshard if one client goes too big, noisy neighbor, all of those things, right? Some people were okay having their data co-located, so you have one big shard where 10 other customers are there. So all of that plumbing had to be done into the code, and like 15-20 days. So we put everything together and sort of worked it out. But I think that was again a good learning experience. Learned a lot about how to move data around between instances and whatnot. And that's where we decided, it's probably good to sort of move from native. So we used to run Postgres on EC2, then we moved towards RDS, and RDS used to give some of these bells and whistles out of the box. So that's another sort of big initiative that we picked up. But before that, till the time we were running a single instance with a read replica, a lot of times what would happen is, DB CPUs would run very hot, and middle of the night you're getting a call from, I don't know, some office in Pune, or some office in Electronic City, or some office in Gurgaon, saying that, hey, I have 200 guys standing in my lobby and your system is not working. It is 2 a.m. at night. Fix it. Right? It was very, very. So those are challenges, but also very, very fun times, because you at the moment you had to figure something out. So we used to always have a fallback where we would basically, somebody would run a script in the backend, download all the trip sheets which the drivers were required to execute, and then sort of send it over an email and say that, this is encrypted, go use it. Use this password to decrypt it and print it out and share it. So we had a fallback tooling as well, because till the time you're running a single database, it's very, very difficult to predict when things can go wrong, and especially when you're growing. And we used to have these customers who suddenly would have a lot of traffic, or some days they would have an event where suddenly, instead of a 200 member trip, suddenly it becomes 1,000 member shift, rather, not a trip. So it's a 1,000 member shift or a 2,000 member shift, because they have one big annual event happening. All of them come together and go together. So that's like a peak load situation. But the most fun thing was that you were touching daily lives of so many drivers. And I think by the time I left MoveInSync 2017, I think we were doing north of 200,000 trips daily. Right. So very, very interesting.
Is still operational?
Yeah, they're big, actually. I think probably in the next couple of years they'll probably IPO.
Nice.
Yeah,
nice.
So they've grown, and COVID hit them bad. So COVID, nobody went to office. So that, imagine that entire thing basically came crashing down. That's when they started working on this. I was not there, but all the credit to the team. I don't know how they managed it, but they basically built a system for managing the hybrid workplace.
Of course,
because they anyway knew what time guys are coming in, who's coming in what day, what time. So they could actually manage the
time
floor
sharing
capacities
of your hybrid workplace. Okay.
Correct. So they kind of launched that adjacency, that picked up, and then this is also now going on. So very, very interesting. Now I think it's probably 1,000 member team out there, and joined them like 8 members. So a lot of growth and a lot of interesting, a lot of heated moments, a lot of firefighting. That's the fun part of it, I think.
Nice. And what after that?
So after that, I joined another very small organization. I think MoveInSync I quit because not much was happening on the engineering side after, I think 2017, middle of 2017.
Ops heavy business at the end of the day.
Yeah, it became very, very ops heavy, and most of the product was already built out. So we were not getting a lot of customer requests in terms of features, this, that. Kind of knew that we had done 90% of it. So I moved to a small organization. I think about 18 months I was there, and it was a very short stint. Because I'm used to sort of longer stints. Like I was on 6.5 years, MoveInSync 4+ years. This was only 18 months. So I joined them because these very young, 28, 29 years, two guys who were basically running a very small setup, 15, 20 odd people, and they had basically built a lot of Facebook apps. Okay. So you used to have these apps in Facebook where people would, flash games and whatnot, right? Those kind of things. And they had
Farmville kind of stuff.
Yeah, Farmville kind of. So they did not even have Farmville. They had a very, very vanilla versions of things like, hey, you can take this quiz. There are 2-3 screens, and they'll ask you some silly questions, and you basically, who's your best friend and what, some such thing, right? Very, very silly stuff. And they knew that this is very, very silly, but it somehow went very viral, right? And they had almost like north of 100 million registered users in US, which was pretty amazing for a size of US population. They had 100 million users registered. At least once they've used their quizzes. So they basically had a very small Node.js thing running in the backend, because everything else was on Facebook, right? All you had to do was serve your own quizzes and whatever games. Then there was some ads element to it, so because that's how they were basically making money. So in between the screen switch, there is some native ad that is popping up, or some banner ad, or some such thing. So this was running, and one or two of these quizzes went viral, and they basically literally overnight became like multimillionaires sort of a thing, right? They was
Nice.
that big, right?
Yeah.
Europe, US, it somehow, and nobody could really understand why, because that's how virality works. And
Correct.
so you could not have predicted. So now they have like, they're sitting on like loads of cash, and they don't know what to do.
Okay.
So they're like, okay, this is a good problem to have. We have money. We can hire somebody who will tell us, what to do with this. And we already have a platform where we have these many engaged users and whatnot. So they had a content team which was basically creating all of this content and pushing it to the application. The application was running on Facebook. Everybody was happy, making money every now and then. Something will go a little bit viral, and they were happy about that. So I joined them, and it's called PubNinja. So they were like, she, you know what, you will have to play both the product and the engineering roles, because we don't know what to build and we don't know how to build, right? So tell us and then build.
PubNinja. Oh, I think I know PubNinja as a, I think,
Platform.
creator platform kind of a thing.
Correct.
Which.
Yeah. So that time it didn't exist as the platform.
Yeah, got it. Yeah.
It exists today. So what happened was, I said, okay, I mean, let's see what we can do. So we started, figuring out what can be done with content. So there were 2-3 ideas. We wanted to sort of work on them parallelly. One was to create a entertainment news website. So we created that website, and it used to have a lot of quote unquote entertainment content from UK, US. They would talk about all the page 3 stuff, and UK royal family, and the princess getting pregnant and whatnot. So all sorts of
Yeah.
stuff, right? And the idea was that if we can be fast about it and we can push it out, maybe we can beat some of those goras in their own game, basically.
Yeah.
Right? So this was one of the ideas, right? The other idea was Facebook anyway, because that was tried and tested, and then we were thinking of other things. Suddenly what happened, and they were anyway getting the user stream from Facebook, right? So they were able to sort of use that, farm that, to kind of push some of this content as well. And the idea was to build personalization around that data, because we had hundreds of millions of users whom we knew how they interact with the platform. So if we could build a personalization, and this is before all that Gen AI and all that,
Yeah.
right? So very, very vanilla AI sort of a thing. So we were looking at models like that. We were building stuff which could potentially predict the engagement on a certain Facebook post or a certain Instagram post. How do you do that? So we were exploring models around that. Again, I didn't really have an AI background, but since I was heading the thing, I was probably read up a few papers, tell the team, okay, let's try this, let's try that, right? That kind of thing. Then one fine day, this whole Cambridge Analytica blew up.
Yeah.
Right? And that's
APIs
when
got shut down.
that's when Zuckerberg had to take a call, shut everything down, and we had zero access, right? Because it was all running out of Facebook.
Yeah.
And
That's
was
when all these games also died, because
everything, right? Or the party came to a stop. So like next day, everything shut down, right? So they were like, okay, now what do we do? We still have the team, we still have the cash in bank, we don't know what to do, and we don't know how to do. So that's when PubNinja happened. So that's when they start, because they were engaging with creators already, so they had a network.
Right.
So we said, okay, if we can build out a B2B sort of a thing where individual creators can come and they can create their own blogs and they can monetize it. So we built some monetization tools and stuff like that. Very, very basic ad tech. That was the first time, probably the only time, I looked at, okay, what is Google AdSense and how does it work? And, what is, server side rendered ads, and, bunch of other things, right? Real time, used to call that bidding, RTB, right? So all of those, that was very new for me. Ad tech is not something that I'd ever experienced. So we looked at a lot of stuff, and we thought maybe there's an opportunity if we can take some of these very mom and pop type of blogs, or very individual centric blogs, and sort of give them higher monetization.
Right.
That's where we could make money. So that's what we started doing. that was not really fun in that sense. It was not really at that scale. So we built that out, and I said, okay, maybe I should do something else. So that was like, a
Yeah.
brief
I think COVID happened and they
yeah.
banked into creator tools because the
After,
creator economy picked
yeah,
up after that.
create, so that must have
That's
grown,
after you had left, yeah.
yeah, after I left. But yeah, we created that B2B thing, and then I quit. uh yeah, so then since then it's been HackerEarth.
And how did HackerEarth happen? Like,
So
what interested
HackerEarth,
you in this?
yeah. So HackerEarth, actually, Sachin, who's the CEO, co-founder, he had reached out to me a couple of times while I was at PubNinja, and I also had interacted with the HackerRank guys earlier,
Huh.
and they were interested in bringing me on board. So I knew the space a little bit, but not very closely, and I was in touch with these guys for I think about 12 to 18 months, and finally when this was not really working out, I said, okay, let's talk to HackerEarth. And at that time I think they just did their series B. So they were like, we're thinking about these initiatives and we have a team. We need to have proper leadership. I think back then there were some people issues as well, a lot of attrition, and the platform was not very stable. Usual stuff that happens with any startup, right?
Yeah.
If you're growing, these things happen, right? So they needed somebody who can sort of come in with some experience and sort out product issues, robustness, delivery, and obviously the people side of things. So sounded like an interesting challenge, and I said, okay, let's figure this out. Sachin was moving to the US, and Vivek, who's the other co-founder, was the CTO back then. So I joined them as VP of engineering, and 2019, yeah, 2019 Jan. So joined them, and started realizing that it was quite a uphill thing. Quite a few challenges on all fronts, right? People, technology. So again, same thing here. Like, we were running on native database, single instance, and we saw how do we scale it, kind of problems. Platform itself, while it used to work, I distinctly remember, like, it back in those days, every day we would have like maybe a 1 minute blip where it would just go down randomly, right? Some spike somewhere and it would go down, then come back again. So people are like, okay, 1 minute, not a big deal. But then what we started realizing was that if it happens during a time when, let's say, there's some campus drive happening and hundreds of students are actually taking
Yeah.
a test, that would be a very, very bad experience. So you kind of need to have some guarantees around uptime and whatnot. So we took some of those initiatives. We said, okay, currently looks like we have a 99% kind of an uptime, which is okay, but it's obviously not great. So let's see if we can bring it to 4 nines. Right, so first from 99.9 to 99, yeah, from 2 nines to 3 nines, and then 3 nines to 4 nines was the eventual goal. Took about 2 years to get there, from 2 nines to 4 nines. And the first move from 2 nines to 3 nines was probably much easier. Low hanging
Low hanging
fruits,
fruits.
right? Okay, some native stuff, let's move it to AWS. You don't want to care about, because you are running a lean team, right? You
Yeah.
don't want to sort of take a lot of overhead in terms of infrastructure management and whatnot. So did that, and then a bunch of APIs which are probably taking 200 milliseconds or 300 milliseconds should be done in like 50 milliseconds or so. You kind of optimize those. So we did that. Honestly, there's no sort of silver bullet, like there's one thing that you do and suddenly your availability improves. So you like do a whole bunch of things, and everything put together, you kind of get to where you want to be. So maybe 50-60 different improvements in the code base, and maybe you need to refactor some stuff. So I realized there was some issues around. So we support about 40 different languages, and which means 40 different compilers or interpreters running in the
Yeah.
backend. And then what happens is, if you have to scale this, sometimes it's a little bit challenging, because you don't know which language will get what traffic.
Okay.
Right. So while top five are probably JavaScript, Python, and Java, and C++, but sometimes you'll get some 100 odd customers who want Rust, or who want like Kotlin or whatever else. So then that was one of the challenges. So Then there was another challenge around, okay, you're doing this in the browser, so how do you support autocompletes and things like that? So we had this whole language server,
The one that Microsoft
correct,
made for
LSPs, yeah,
yeah.
yeah. So we had that set up for I don't think we have that for all the languages because it's not supported.
And for compiled languages, it does not really work that well,
Yeah,
I guess.
it doesn't
You
work
need
that
a
well.
cloud side worker and all of that stuff.
Correct. So that had to be optimized, and there we used to early on when I had joined, I think we used to have one LSP server supporting one user. So then we had to sort of make it many to one sort of a thing where we could multiplex and support multiple users in the same server, and because it was very infrastructure heavy, and it used to take time to actually launch those servers. So if you were say supporting a drive which had 10,000 candidates, then suddenly you need to launch those 10,000 SP servers for each individual candidate. That was resource intensive, and also it used to take time to kind of ramp up. So we made those changes. I mean, bunch of. I think one of the other interesting problems, and this is probably for the developer audience who watches you. So we have this interesting problem where we have to basically do a plagiarism check,
Yeah.
right? And you know, uh, we we've built the at least we try to sort of build features in a manner where we can say theoretically support at least 100,000 candidates in a single event, right? At the same time, sort of a
It's
thing.
the whole original Stanford Moss paper, right? Nature of software similarity.
Correct.
I built an online judge myself, so
Oh, is it? Okay.
yeah.
Yeah.
So my
So
first startup coding blog, so we had our own online judge and everything. So
correct. So we had this. So we had this problem. Okay, so if you have 100,000 folks writing code, and then you have to sort of do a plagiarism check across
yeah.
so 10 to power 5, 10 to power 5,
Yeah.
you have to do n squared, 10 to power 10. So you have a billion comparisons to make. So how do you sort of start from there and then cull it down to a more manageable problem?
Correct.
And then apply Levenstein distance, which is like classic dynamic dynamic programming problem. So that's what we ended up using. But obviously we could not have done an n square comparison. It was
Of course,
very
yeah.
time taking, right? So we said, okay, rule out folks who have written 2 lines of code anyway, not gonna work.
Yeah. You do the
Do the scoring
basic culling
correct.
first. Yeah.
So all of that noise was removed. Then we probably left with like maybe 10%, 20% of those, and then figure out how to do this. So that used to take time, and it was all in async flow, so we had to optimize that. So a lot of these stuffs were running async. But the challenge also was at the same time that customers would want to see these reports in real time. Like as the test is happening, they would want to see how many candidates are scoring how much, how have they done.
All of that stuff.
So the reporting is also very real time. In the backend, it was all sort of messaging based, and we used to use RabbitMQs and Redis for most of these use cases. But to update these reports in real time. So for instance, if there are 10,000 candidates taking, and one guy basically is trying out one programming question and he submits, then we update that one report, but at the same time we also have to run a plagiarism check,
Yeah.
right? So that became a challenge. So how do you do that in real time? So we said, okay, probably the not a good time to run a plagiarism check while the test is happening. Maybe
That you can do
later.
at the end and add the disqualifications later.
Right. So those kind of things.
Yeah, I remember we used to run contests like that on our own judge, and
Yeah. So I think plagiarism was one part, and then I think some of these classical engineering problems we talked about, LSPs, we talked about how to scale sort of compilers and
correct.
working with the concurrency a little bit. And see, at HackerEarth, it's not so much about absolute scale, because if you look at say consumer businesses, we're talking about like 10,000, 20,000, 100,000 concurrent users, not a big deal. But the kind of platform that we have, there's
every request
yeah,
needs a big infra to run it, kind of
the
thing, right?
infra, it's very
compute
infra heavy. Yeah, it's a very infra heavy, compute heavy. So the infrastructure part, the core of infrastructure and the architecture has to be very optimized. So for instance, a couple of years back we launched this feature where you could come in and solve a full stack problem on HackerEarth. So you could actually take a bare shell Unix thing and basically install Node, install React libraries, and build a front end, build a back end, tie them up and actually run the entire application. Right. The idea was that, look, while people, sort of assess developers using classical programming, there is a definite need for folks who want to, test this side of skill as well, right? Which is application development or web application development. So we built that out. And again, if you have to sort of scale that, it's like as many number of EC2 instances, because ultimately in the backend, it's like
Each
one
box
compute
is
instance, right?
Then
So
you would also work on encapsulating the box properly, because it's other people's code that is be running on
absolutely,
your infra.
absolutely. So you have to harden the box in a manner where you have appropriate checks for TLEs and MLEs. I mean, basically limits in terms of how much memory you are giving it and how much time for execution. Otherwise, somebody writes a nice little infinite loop and you're screwed, right? So you have to
People
stop.
can fork bomb your because
Correct.
it's kids who are working on the platform. It's like
Right, right.
people try to abuse it in all sorts of ways as well.
Correct, correct. So you have to have appropriate guardrails and then sort of scale it. So that part of, I think, if you look at it from a very high level and kind of tying back to your original question, this the reason why I joined and how HackerEarth happened was also because I felt that this is one of the places which is obviously built by developers, but it is also for developers and is running at a certain scale. So that should be fun, right? So that was also the one of the motivations. So every day you were talking about developer problems, right? And then solving it through code. So that was interesting. So coming back to the project type of problem, right? So you can, then we said, okay, if you can do maybe Node.js, you can also do maybe Spring Boot, and you can then do front end, you can do Vue.js, and you can do Angular. And then so we said, okay, if we were to do this, maybe a better way to do it is package all of this in some sort of Docker image, and then give that out of the box so that people don't have to do the initial setup part, and they can just come in and start writing code, right? So we had to build that part out, and then so then it from launching EC2s, it kind of became a problem of launching so many Docker images, or and so we said, okay, instead of doing bare shell EC2 horizontal scale out, you basically use something like ECS, which is basically a container service thing, and then you give it images and then let it spawn the tasks, so that at least the orchestration part can be offloaded a little bit. So this is these are all, again, engineering problems for engineers, kind of a theme running all the way. So a bunch of interesting problems. Like, again, one of the problems that we had was how do you say, a customer comes and says, hey, you know what, I have the JD right now, I want you to create an assessment test for this JD, right? So
Interesting.
So you basically parse that JD and write an algorithm to figure out what are the key skills. And so we did a sliding window sort of a thing and pulled out all the skills, and then automatically create a test. So write a small algorithm for that. So a lot of places you have these, again, people call it AI and then whatnot, but you sort of have these baked into the system. Like people want to know, okay, I have these 10,000 folks who have taken my test, but if I have to review even the top 10%, and that's like 1,000 folks, and I have to go through all of their code and whatnot. So can you create in English language explanation for what their code is doing, right? So that's where the AI sort of again comes in. So we did that, doing complexity analysis of the code, giving that data, code quality checks, Sonar Cube, bunch of things, right? Then somebody comes along and says, hey, you know what, I want to assess machine learning engineers and AI engineers, right? So they don't want to write code in your VS Code or whatever else you're doing on the browser. So they are used to Jupyter notebooks, right? So it's like, okay, Jupyter notebook we can do, but then the moment we start setting it up, it looks like you can do one, you can do two, but the problem is, how do you scale it again across thousands of users, right? Because anything that we do has to be able to scale. And I think the default architecture that Jupyter notebook kind of works with, it has a hub and a notebook server. So the hub can at max, you can't sort of scale out the hub part of it. So hub can run only on one server, and then it can support whatever number of servers it can support. But because this is a restriction, you can have one hub running, and then maybe it can support 10, 12, 20, 30, whatever number of notebook servers. That doesn't work for us. So you have to kind of dig into the open source code and sort of wire it differently a little bit so that the hub can also be horizontally scaled out, and then you have support for thousands. So those are the kind of problems that we keep on solving every day.
No, it's nice, interesting. And so I mean, just sharing, because you was talking about like hardening that system. I remember like when so in my first startup we had built something like a code judge, and then obviously like it got used by a lot of colleges actually, because they used to have events and also we never went into the hiring space or the enterprise assessment space, but is mostly used by students. And we were a net tech company and we used to make money from the ed tech side of it and not really from this. So this was like a thing on the side. But then some colleges were like, we want to run some hackathons, and okay, initially it was like, okay, we'll use this system, and it was like the typical DSL Go coding part, and we had a front end setup as well. But then somebody said that, okay, can we do something like Django Express kind of assessments also on that?
Correct.
And when we did it, one of the first things that happened was somebody abused that to I don't know, makes like bunch of DDoS requests to random stuff, and and then we were hosting a DigitalOcean, and the DigitalOcean, so we were sort of, because of we were doing all of these things, we used to be one of their earliest and biggest users of their managed Kubernetes kind of service and all. So they had a hotline with us, and then their India manager, they reached up and like, dude, we got like a bunch of this whatever DMCA request, and you're scraping videos from YouTube, hosting here. One of these things happened, and the other thing happened was somebody was making a lot of DDoS calls from this thing, and like, oh, okay, like these IPs are yours, and I'm like, I mean, we don't run stuff like this. And we're like, oh, this must be some of the people running code on our system. And like, oh, okay, we'll need to now encapsulate against all of this stuff.
Correct. So, no, that's a big requirement actually. And the good thing is, I mean, good or the bad part is that it cannot even be visible to the users. Like for the users, it should still be like, you've given me a bare shell thing, and I can do whatever, right? And obviously, you need to have underlying
eventually
controls.
We did. So we figured out how to have a copy of NPM also, because we figured that that's causing a lot of
you'll have to make internet calls and whatnot.
Too many internet calls for NPM. So
right.
I mean, it's not to prevent access to NPM, but because it can reduce the downloads if we just have on the locally, private cloud a local copy of NPM.
Plus, you will have to allow ingress egress for those many number of external endpoints as well. So that also is an opening.
Then we ended up proxying NPM. So and this is like me just 3 years out of college, so learning all of that was fun. Building that.
No, that's why I said I think building for developers is a very different challenge, right? Because they are thinking just like you, right? So whatever you're trying to guard, they kind of already have a thing for that. So recently, all of these once ever since ChatGPT and Claude and whatnot came about, candidates are all about I can just switch my tab and kind of go to another tab, put this browser statement, get a code and sort of copy it. So we've had to do a lot of stuff to kind of prevent that as well, which is again not something that you would ideally want to do.
That's what I have been I think there were a few clients who used our platform as assessment back then, people I knew and all. Like I was saying, that's not our primary business. But then I sort of backed out of it when there were a lot of requests for doing what used to call proctoring. Is the word, I don't want to waste time figuring out whether somebody's cheating or not. I mean, I'm happy on the learning side of it, because if they're cheating, it's their loss, and I don't care about that. But I understand that.
And that's a P1 requirement. That's a very, very important requirement. In fact, that's probably the biggest, ask that most of the Indian enterprises actually have.
From a pure play assessment side of things, proctoring is like a core tenet of it.
Absolutely. It's a very tier 1 sort of a requirement, and we had to do a bunch of stuff to kind of capture. Plagiarism obviously was there, but that really doesn't cut it. So what then we ended up doing was we enabled webcam access on our assessments, and then we capture snapshots and then sort of computer vision YOLO sort of models we kind of apply and see, okay, is the candidate actually present in front of the system or not, or are there multiple folks sitting in front of the system, or recently I think the last one that we did was candidate sort of looking in a different direction,
the eye
tracking. So we built all of that to kind of just and then on top, because there were so many checks now,
Yeah.
right? You had plagiarism, you had these webcam based 4 or 5 things. Then we built something like mobile detection. Somebody sitting with a mobile and sort of googling something there, you kind of detect that object identification kind of thing you do. So we did so many things on the proctoring side that eventually we had to build a layer on top of it, right? And say that, hey, this is the final abstraction layer which will tell you whether the guy has cheated or not, right? So so there itself we have like one layer of architecture happening. Yeah, because it's simply not possible for you to sort of go through all of those individually and figure out what is happening. So we had to do that. We call it integrity score, and finally, so that was another interesting problem that we it's a continuous thing, honestly, right? We detect for folks who have say something some browser extensions, right? We had to go to the point where we said, if you have any browser extension, we will not allow you.
Do you think, I mean, just the idea off top of my head, and I have thought about it for tools which do proctoring, something like making it a desktop electron wrapper app?
That's exactly what we've done. So we have that option as well.
Because that way
there is some friction to adoption there, but a lot of enterprises are actually okay doing that. They're like, I will enforce this. You give me an electron app. So we did actually an electron app.
That way you can
control all
these things, and you can also, like, because it's a standalone process, you can monitor for what other egress is happening on the machine and all that.
Absolutely. So we have that. So we call it the smart browser kind of thing. But we have done that already, and that I honestly wasn't very sure about it when we were doing it, and I was like, almost like telling my product team, what, this I don't think it's going to adopt it and whatnot. They're like, you have no idea how bad they are because of this proctoring, so will do whatever. And they were right. I was probably wrong.
But like, I think in a captive assessment environment where like the assessor can ask the SSC to install whatever software they need to, I think there it's that makes really sense. Fine.
Yeah. In fact, not just in hiring, folks are using this for their L&D use cases as well, like learning and development within their organization. They're saying, you will not use your browser, you will use this electron app to kind of do this, because it's crucial for them. So there are those kind of customers as well. So I mean, there's a lot of these interesting problems that are sort of being solved every day, and we kind of keep getting this, and that's the kick of it all, right? That you every day you sort of encounter something interesting. Here also, I think we had some scaling bottlenecks that we solved for. One of the sort of war room sort of situation, actually not a war room, because we didn't really get time for it. So our sales team basically comes and says, hey, you know what, we're onboarding this say the biggest IT services company in India, right? Whatever. And they're like, we will do 50,000 concurrent candidates. Everybody logs in at the same time, logs out at the same time to our test. And back then, and this is like, I think 4 years earlier from now, and we used to do 5 to 10,000 regularly. We had never really we had probably tested for 10,000, 15,000 sort of a load. They were like 50,000 concurrent candidates. And again, the same whole jing bang, right? You'll have to launch compilers, LSPs, or all of those things, right? And then there was this database, which was still sort of one read replica and one this. And we used to have some async flows through RabbitMQ. So we got about a couple of weeks to kind of cater to that request, and we said, okay, let's figure it out. And my team was like, this is not happening, right? I mean, we can't, like, in 2 weeks we can't re-architect the system, obviously. And it is what it is. So we have to ask them to sort of break it down into multiple different events, hiring events and whatnot, not 50,000 like in one shot. So, but that apparently was the only reason why they were coming to us, because they had gone to competition.
Who had said no to?
Who had said yes and failed. And actually, I don't know whether they failed or they something like that, right? So they came to us, and like, no way we are going back to them and saying anything like that. So let's put our heads together. Let's figure out whatever we can do. So I said, okay, let's start with 10,000. Let's ramp it up to 15,000, 20,000. Let's build a test harness. Let's see to what extent we can scale. And wherever we'll find bottlenecks, one by one, we'll have to resolve them. Essentially, there are two facets to the product. One is the admin side of things, and the other is candidate side of things. So candidate is what we had to scale basically, right? So in the backend, everything that comes on the candidate path has to be scaled horizontally. So we started working on that one by one API at a time, one database call at a time, one query at a time, doing that, right? At the end, we kind of reach about 50, 60,000 kind of a scale, and we're like, okay, I think this can be done. So they're like, okay, are you guys sure? I'm like, yeah. And I'm somewhere like obviously not 100% confident about it, but I gather everybody in the team, I think few days before the actual event date, and I'm basically telling them a story from Constantinople, the fight of Constantinople, just to energize the folks. This is a big thing that is coming, and we got to do whatever it takes, sit overnight, let's fix whatever, like proper war room situation, right? I'm giving the examples of how the Ottoman Empire did this and that. So like a lot of stories, and obviously we were in the back end, we were also fixing stuff. Finally, the D-Day comes, and we have like multiple monitors set up for various alarms, and I was somehow under somewhere I was not like 100% confident. I felt like this rabbit MQ thing will basically take us down because it was a bottleneck, and we could not have scaled that infinitely because it runs on specific hosts. Correct. So I was kind of worried about that. Time comes, we open the floodgates, and we get the thundering herd that we were basically expecting. 5,000, 10,000. It's basically scaling up every minute, right? One thing which I had least expected was that candidates are not even able to open the candidate interface itself. Like on the landing page itself, something is broken. And I was very surprised, like, this is where it starts, and we are not even doing anything here. So how is it possible that the landing page itself is broken, and it's taking time for some guys? You know how it usually happens. It's not suddenly a blackout. It's a brownout, and then it's a blackout. So it is browning out. We are hearing, okay, one candidate, two candidate, 5, 10 candidate, and suddenly everybody says, right? So, and we are watching the alarms. Then I noticed that DB CPU is like 10%, 20%, and we had provisioned the biggest AWS instance available to us, right? Biggest with a read replica. I think 64 GB or 128 whatever was available back then. So reaches 100%, tops off, and like not happening. Like the people are not even able to get through to the actual interface of attempting test. It was a royal failure, right? We could not support it, and obviously we got a very, very sorry figure. And I basically told my team, don't worry, it's fine, things happen. I told them, and then we all gathered in a big conference room, sales team, marketing, everybody's there, and I basically have to address them all first, and then sort of get to the customer call and explain to them. So I told them, like, we tried, there is definitely, and by that time we had figured out what was wrong. So I'll come to that later. But basically I had to address them with a very, very straight face that, look, we tried and we failed, right? I mean, there are things that went unnoticed, and this wasn't expected. I will get back to the customer, and we'll obviously have the sales guys and the CEO, everybody talk to the customer and get ourselves a second chance at it. So that was basically the story, the first part of the story, right? In the background, basically what had happened was on the landing page, right, there is an API which basically determines what is the order in which these questions have to show up for individual candidates. We call it the shuffle order, right? So this shuffle order has to be pre-created before they enter the test, because the moment they enter the test interface, they will see the questions in that order, right? So this API has to be called. All the performance testing that we had done was for the interface and not for the shuffle API. The shuffle API somehow was never on anybody's mind, but this had to be called for everybody. This is like on the gate, right? They had to pass through that. And this was the one which basically, took us down. One API which we missed. We had tested everything in and out, and we were confident about the 55, 60K, whatever comes. And they were like, we are telling you 50K because those many have registered. Maybe it will turn out to be 40K in reality or 35K. So we were very confident about everything else. But this thing, nobody sort of realized in time, at least. But when all of this was happening, we kind of figured out that this one thing is the thing that is causing it. So anyway, we couldn't have done much. Everybody went back home. Incidentally, that was the day when everybody was also told to start working from home because COVID had hit.
Yeah.
So we went back to the customer. Customer said, you know what, it's okay, let's give it another shot. And like, okay, we get another shot at it. So that's when we basically, I think after 15 days, we again tried it and it worked, right? And everything was like absolutely fine that time. I was like, thank God, right? But there are those moments that you live through where, you're just watching your graphs go up into the stratosphere and basically hitting 100%, and you feel like everything is out of control. That's just part of life. And like, but yeah, interesting times.
I remember something very similar in the problem. Like I think the details are very different, which is so there was this another big IT services company, which is like the co-founder was one of the investors. So they wanted to use our platform.
Correct.
Okay, and like I said, I mean that's not something we were in the business of doing, but we used to do hackathons, college level hackathons and all of that, and typically we would not do like hackathons which were like 1 hour 2 hour kind of ones, which were like you have a 15-day period of submitting things and those kind of stuff, like make an app and submit and these kind of things. And then there was this hackathon which we were going to do, and so we did it for 2 years actually. For the first year, what happened was so there's going to be some 20,000 people who would participate. That was expected. I was like, okay. And this company, obviously, this is a tech company themselves, right? And they're like, okay, these kids running a startup, they did not trust us. They were like, okay, we want to load test. Like, okay, give us all your APIs. You have to run our system on our cloud. We hosted. Okay, we did that. Okay, like, oh, we will load test. They load test a bunch of stuff. We had to I think overscaled almost 10x to what it was required because they had to load test everything. And I think the funny part was like because of like the way we ran, there were certain services which were not running on their cloud, which we still had to scale up our cloud because those were like upstream and they were connected to our system. So we ended up spending more money than they paid for us to host that event because their performance testing we ended up absolutely wasting more money. Infrastructure, and I think cost, they paid us few lakhs of rupees to whatever to host it, and then we spent more money than I had to test it. But yeah, I mean, but one thing we noticed was that in the actual event, because we were supremely scaled up, we did not actually have a problem, but they tested a lot of stuff like around the code submission thing. And they were like, okay, the two things is like this was like a 3-hour window, so like whatever, like 7 p.m. to 10 p.m. So at 7 p.m. everybody will try to log in, and they wanted our login APIs to be like 10x scaled up because everybody will try. I'm like, okay, fine, whatever you say, right? I mean, we were kids, and they're like big honchos who like have been delivering tech to a lot of companies for whatever you say, we'll do. Okay, fine. So like, okay, fine, our login API is 10x scaled up, and then they're like, at the last minute, people will submit their coding question, and your code runners submit has to scale. The code runners have to be scaled up again for 20,000 people. So you scale up to almost like handle 1 lakh because people might submit 5 times. Like, okay, fine, we'll do it. Okay. The one thing that even they were not concerned and we were not much concerned, and we realized that the actual test was like there were 3 coding questions, one front end, make a front end question, and there were like 10 MCQs. What happens, like, people always keep the MCQs for the last. They're like, okay, let me do all of this and I will fill the MCQs because the MCQs don't have negative marking. So like, okay, I will fill something anyway. So in the last 1 minute, everybody just fires the MCQs. Like, and it's like, all 20,000 people. And then, the thing is that what we realized that there were about like 10-15% people who actually even ended up starting the test late also because they did not remember, got a reminder. But the ending is really same for everybody. It's like all 20,000 people, and they tried all, like not all 10 MCQs, not all of them, but a majority of them trying all the MCQs right at the last 5 seconds. And that actually spiked up and actually utilized almost all of the scale up we had overscaling we had done. So when we did it next year, I was not interested in wasting all of that money at all. I was like, dude, listen, here's my way of doing it. All my life, buying sports tickets and concert tickets. I know how Ticketmaster works. We're gonna put everybody into a 15-minute queue. Every 1 minute, 1/10 of the people will be starting. So the start time is not gonna be the same. Some people will start at 9, some people at 9:01, some people at 9:02.
Correct.
That's how I will stagger. So that when they end, it's like not at 10 p.m. everybody ends. We will end from 10 to 10:15.
Correct.
And that worked really well because the load got distributed. Like by doing 1/15 means the load got distributed a lot.
That
because
is
everybody's
very easy.
Like last they have a countdown timer at the top. 10, 9, 8, 7. That's when they will fire all the MCQs.
Everyone is submitting at that point. Correct. No, we had to actually do things like auto submit and stuff on code. So sometimes the complaints were around, I wrote all the code, but the time got over. I could not submit.
So you have to do
auto submit. So no way you are actually getting away from the concurrent submits anyway. You have to do it on your own at the end anyway. So we had to but those are funny problems. And you are right. Actually, the infra cost for doing the perf test sometimes is much higher than the actual event. That is there. That is true.
So especially for something like this, because the actual number of users is not all that high, but but you want to make sure every node in it is working, and that's pretty costly to do that all of that test. But that's fun. And so I want to change tack and obviously talk about something, because we've been working on this space for like half a decade or so. What changes do you see in terms of like how companies use assessments for hiring people? I mean, people on the streets keep saying that a lot of companies are moving out of purely assessing people on just DS algo based questions, and people want developers who hit the ground running, and they want to assess more based on that. And like you are right at the center of it, your tool is used for that. Do you see more of that happening nowadays?
Yeah. So I think if you were to ask our customers, they would say, I want developers who can do everything. Right. So obviously they would want DS algo guys who can also write Node.js equally well and create an application. But I think truth be told, even now, I think about good 60 to 70% of developer hiring is all DS algo based, at least at the entry level. And that essentially forms the bottom of the pyramid. So maximum number of hiring anyway is happening there. Right. So DS algo is still by far the most prominent set of skills that we test people on. But this project type web application development, etc., is obviously picking up very well. And this is growing exponentially. Right. So, like I was telling you, a couple of years back we launched, and I think in the last 1 year itself, it has grown more than 10x. Right. The number of candidates who are attempting these type of problems, the number of customers who are asking for these type of tests. So I think we're seeing a lot of fast growth, but obviously the base is lower, so it'll take some time to catch up. So we may be doing in the multiples of 100,000 assessments every month. Right. So this is probably somewhere around 10% right now. And the other set of things, but I think it's picking up really, really fast. So that's one. And obviously then there is the other type, which is people have started asking for DevOps skill set as a separate, because there's a new job family. For whatever reason it exists, right? I mean, there's a DevOps role, right? So, I mean, if you had asked me 10 years back, there will be a DevOps role, I would have laughed and I said, there's no way you need a DevOps role, because that's what an engineer is supposed to do, right? But it is what it is. So there
cloud has become complex,
right? So there are SREs and DevOps. So we have a separate set of questions. Again, they're almost like project type, but instead of writing your framework code, you're basically setting up a Docker and setting up a Kubernetes cluster and doing something on Puppeteer and Ansible and those kind of tools, right? So again, start with the bare shell and do something for there. So there's that type of niche that is also picking up. Then we talked about machine learning, right? So Jupyter Notebook kind of interface. It's for all the noise that is there, honestly, it's not really converting into a lot of business for us, at least as of now. People want AI skills, but now I think AI has reached a point where everything in AI is also become SaaS. So now AI is more like, hey, you know what, integrate with this Hugging Face API and you're done.
Yeah, I mean, from what I see is, I mean, there were some companies recently I was consulting with, helping them hire people, and they are like true blue AI companies providing AI solutions.
Correct.
One of them runs their own model as well. One of them uses like wraps over some open source models and all. And like whatever, like the initial product, some bunch of scrappy founders put together some models, showed some demo, raised some funding. But like the next stage, everybody is looking to actually hire just regular senior engineering leadership and senior engineers, because like, okay, we now need to set up our infra and we need to sell SaaS to people, and then like okay, like the core model we'll keep tinkering with it, but I mean
you need the bells and whistles of SaaS.
So most of them are facing the challenge of like, okay, it's at the end of the day some C++ or Python code, and then the sort of embeddings are in a vector DB. Many times it's in Postgres also. You can store some of them. Postgres, but then how do you like scale it up so that I can handle 100K requests, and for that I just need vanilla software engineering skills to make this thing happen.
Correct.
And that's what they are kind of hiring for.
So I think that's what we are seeing. And I think even though we've kind of gone ahead and developed stuff like questions which will assess candidates' ability to do, say, data wrangling, and then do maybe some amount of model training. In some places we basically give them say access to some foundational model and then give them some data and say fine tune this. So those kind of things we are starting to build. There isn't much traction right now, but I'm guessing it will sort of in due course that might pick up. The other side, like you were saying, is more sort of leaning towards data engineering capabilities, right? Where people are like, okay, I have this much data, you have to pass it through some sort of a Spark cluster and then processing on top of it. So we're doing that. But yeah, that's so people are picking their niches, especially for lateral roles. I think that's the inclination that, I want to hire a Java developer who has 3-4 years of experience, or a Node developer who has 5 years of experience. Make them do this.
Another thing I want to ask is like, because I've dabbled in the space myself a bit, there are two pieces I feel challenging, and I'd love to know, like, how you guys see it and how you sort of solve for it. I mean, point-to-point questions, like typical DSALCO questions, like the sort of environment challenges around like containing the, fork bombs and, scaling up. That aside, like the basic point-to-point evaluation is sort of super straightforward. Like Spoj has been doing it for 30 years and all of that stuff, right? The two things that I feel kind of more difficult to evaluate, and I feel like, still now more human factors get involved. And I don't see much confidence in removing the human factors in getting involved. One is that the ability to sort of design your code well, like your structuring your code well, low level design, and not just your basic code smell kind of thing. Like, I mean, some of those things like static analysis obviously exists, and your functions are too long, or your if cases
sonar cube, etc.,
too indented, or stuff like that. But hey, I mean, why did you not abstract this property inside this object and the other object? Because so like some of the age belongs to person. Why are you keeping your age inside some other function and not saving it inside person? These kind of stuff. Right. That's one. And the other piece which I feel is like people's ability to actually wrangle with a bit of a messy scaled up system. Like again, like like deploy Node.js on localhost. Fair enough, a lot of people know. But hey, like, I mean, if you actually put it on production, you'll have a application load balancer, an edge load balancer. You have to trace your request ID, and you have to log your body accordingly. And understanding this part, right? So both these two things is something I feel it's not very textbook way of sort of evaluating. I mean, put me in a room with a person, I can evaluate these skills. But then is there a platform? Is there a tool? Is there like a more sort of black box way of doing this, just doing this? So these two things, is this something that you see some light on the end of the tunnel for this?
No, we actually. So what happens is. This part that you're talking about is as of today being covered, during the interviews, right? Now, how do you bring this into the assessment stage, right?
Fair.
I don't think there is a very cookie cutter solution as of today which you can use to sort of solve for this. There are 2-3 ways in which we are trying to kind of move in that direction, right? Which is sort of shift right kind of a strategy. So shift left would be, let's say, something like DS algo, right? So you start with that, right? So that you know that this guy has the basics, right?
Correct.
He can problem solve, right? Or he has the required IQ to sort of work with a certain bunch of people in a certain environment. So you start with that. You kind of cull out folks who are not meeting your bar.
Can't translate thought to code kind
Correct.
of things. Yeah.
So once you get through that, the second stage is where you could do one of two things, right? So we've started experimenting with something called a debugging sort of question type.
Okay.
So we give a whole bunch of code to you, right, in your own whatever languages you work with, and we say, okay, this code is intended to do this, however it does not. Right. Now you go ahead and figure it out. Right. So that's one way, but it's still largely logical, where you will say, hey, you know what, you're missing this edge condition, or if it's a recursive.
But still fair enough. I mean, reading code is a good skill to judge.
Correct,
it's required to judge.
So instead of just writing code in a given method and solving that, you are given an existing code, and suddenly your thought process changes. Now you have to understand that code and make changes there, which is sort of more real time, more real life problem, right? Which is what you end up doing anyway as a developer if you join an organization, right? So that's one way we are trying to solve that. The other way we are, and again, this is something that we do both in the programming flavor as well as in the full stack flavor. So full stack flavor, we actually give you a working application. We say, hey, you know what? This is a Ruby application, let's say Ruby application, right? Rails application. And this is your model, this is your view, this is your controller, and this is what it is supposed to do. These are the different endpoints, and this is the UI. We give you everything, like 15-20 different files, like a proper project, mini project, right? Repo. And then we say, okay, now you make it do this.
Okay.
Right. So again, a functional thing, but
like parachute into a project and
correct, make changes, right? So that's again sort of one step shift right.
Makes sense.
Then the third thing which we try, and again, this is not part of the automated evaluation and assessment, because all of this what we talked about was automated evaluation. The third thing is through face code, which is the interviewing tool. That's where you can actually pair program.
Yeah.
And that's the holy grail sort of a thing. So in a lot of cases, people who are using face code for interviews basically open up repos and say, hey, this is how the code is organized. I'll walk you through this. Now you tell me what are the places where you can improve this. Right. And this could be their actual repos. These could be test repos. This could be new projects that they're working on. So interviewers kind of give that access, and you can basically pair program effectively.
Nice.
I think that's the third thing. So again, not like a single point solution for the problem, but like incrementally you can solve it this way.
Makes sense. Okay, I will come straight to then like the big elephant in the room, which you are talking about, which is about these AI based tools. So I mean, at the heart of it is that I'm specifically talking about LLMs and transformers, which is creating all the storm right now.
Okay.
So I mean, at the heart of it, they are really good at obviously generating textual content, which includes code and specifically like Copilot and Codex kind of things. So how do you? I'll probably, before getting into any specific things, I'll probably just ask a more broad philosophical question. How do you think this sort of changes the software engineering landscape? Just the ability to sort of you can write comments and the function can get generated, or you can do the other way around as well, like give a function and it can generate a documentation for it kind of stuff, right? So how does it like broadly change the software engineering landscape as you look at it?
Yeah. See, I think two ways to look at it. One is, if you've been developing software for a long time, you probably already have experienced this in bits and pieces elsewhere, right? So there are tools which will basically generate the scaffolding for you. You give it the app name, give it the entity names, and it will basically do all the plumbing for you and whatnot. So it's not like this is entirely new, right? Of course. So if you look at it from that angle, it is incremental. But is it truly incremental? Maybe it's a little bit more than that, right? It is a little bit more in the sense that you don't necessarily have to, at this point, even understand what is also going on in bits and pieces. You could just, for instance, right, if I had to today implement Levenstein, I would probably not be able to do that without reading up the algorithm again, and understanding, basically refreshing, how that whole DP matrix was created, and how you create sub problems and then create a solution out of the sub problems. But I'd wager a guess that if you give it to Claude or a GPT 4 or 4 or whatever they call it, it'll probably just give you the canned code for it, which will 99% of the times work. Right. So I think just the abstraction layer at which things can be made functional today has changed significantly.
Correct.
Right. And that does actually change quite a few things, right? It changes the way people have been learning about software engineering, and it changes the way people have been writing code as well, right? So again, if you go back in history, people wrote machine code, assembly code, whatnot, and
then you had compilers which sort of
right, low level languages, then high level languages, and today it's basically becoming the natural language, right? So that's the curve. But I think there is a fundamental change in the sense that the basic skill set required to even understand some of these underlying abstraction details is probably something that I'm also a bit worried and skeptical about, that how is this going to pan out. But at the same time, I do feel resistance is futile in certain moments, because
I mean, that is true. I mean, it's you can't
really
stop it from what is happening.
Correct.
But but one of the things I feel is like earlier such phases which have happened, which have, what I think DHH wrote this blog about compression of knowledge.
Correct.
That, like your ORMs, which
that is happening exponentially,
let you avoid understanding too much of deep SQL wrangling, or compilers which let you avoid understanding microprocessors, right? But those were still very deterministic steps, and it's kind of easy to sort of predict what kind of things can go wrong. And when something sort of goes wrong, like it's more like very rack and pinion, you can see it is broken, right?
Correct.
I mean, say you create a generator, right? I mean, generators like in Ruby and JS world, generators are very common, right? Scaffolding generators and all, and you give a JSON model and it will generate the ORM, or will generate the SQL query out of it. But since it's very deterministic, and if you see an error, first of all, the error replicates, and you can sort of fix the error, and maybe you build a whatever ORM, a query generator, and it cannot handle many-to-many relationships, and only can handle many-to-one. But you can add that feature into it, and before the feature it does not work, after the feature it 100% works. And this is not something like that, because this is more of a classical ML kind of a thing, right? It's like some weights have aligned to give that random output.
Stars have aligned.
It's like stars have aligned. It's like weights have aligned to give you that output, right?
Correct. No, true. So I think, see, I was coming to that. So I think there again, we have to, if you look at it from an engineering perspective, right? I was talking to this somebody else, I think in a conference earlier. The part which you're talking about, which is deterministic, right? Maybe, and just maybe, right? Some part of it will not even be required to be deterministic. And what I'm saying is, this whole generative part of the generative AI, right? Essentially, it is generating stuff, right? So stuff that you are probably pulling from a data source, pulling from a DB query or from S3 or wherever else, you could potentially generate, right? Yesterday, I was talking to some principal architect, solutions architect from AWS, and he was like, one of our use cases is that they used to store whatever number of email templates in S3, and now that is gone. And that's precisely the thing. So you don't need
there
to
are
be
places where, I mean,
correct. So it's a pro and a con. Right? It's pro in the sense that you can potentially customize it far more than what you could using something like this. But the con is like indeterministic.
Maybe that is a problem statement where like the deterministic solution is a inferior solve than to just let it generate templates on the fly every time.
We've been sort of playing a little bit with this, like I was telling you the earlier example, using the natural language to sort of explain the code, right? Similarly, there is this solution that we are trying to create for solving or evaluating essay type questions, right? So people write subjective answers for a given problem statement, and how do you evaluate that? Now the same answer could fetch different marks from different evaluators.
Yeah.
Subjective answer. Now, do you want a deterministic solution for that, or do you want a non-deterministic solution? Probably you want a non-deterministic because it depends on who the evaluator is.
Yeah.
Right? So there are certain use cases where you could do that. But to your point, that is an impact where if you replace a use case where you need it to be deterministic and it is non-deterministic, then it's a problem.
Yeah, because what I feel is that like, I mean, say folks like GitHub Copilot, they tout around stuff. Like, I mean, I was there at GitHub Constellation, and then they have made their whole company about Copilot a lot these days because I mean, obviously that's the flavor of the month. But they were talking about that 60% code being written inside VS Code is generated by Copilot and all that stuff. The thing is, like, I personally, like on my last year or so, side projects and all code that I've written, I've heavily used Copilot myself as well, right? And I understand where the number is coming from. But the thing is that, and I actually made a video about it also recently because I tried, I was making a YouTube video downloader thing, and I just wanted to try out like the full capabilities of this. And I said, okay, let's me try it out using things like Claude and GPT, using Copilot or using directly ChatGPT. And then as one of the ChatGPT outputs after trying out different types of prompts, I was able to get it to actually generate the full code of a Flutter app, right? I mean, obviously it just generated a single Flutter file where the whole of the code is there.
So that's another problem.
There's another problem, but that
it works.
It compiles, and right. But the thing is that I talked about it, that one of the things, I mean, obviously like knowledge cutoff issues, and because the language also keeps getting updated, the code it generated compiles with an older version of that and not with a newer version, because like how you use const and new, those kind of few things changed. And again, like, I mean, it took me 5 seconds to make those changes because I am very well versed with Dart and Flutter when I've written code. But then somebody who is new to it is going to be fairly stuck on that because they have not reached that answer in a deterministic way.
Correct.
So now they have to do it in a black box way. They have to find out what's wrong. And then when I like sort of ran the code there, where obviously like those issues that come out of generative AI not being deterministic is like like the state of the button was opposite. Like when it is clicked, then it is supposed to be filled, and it is not filled, it's supposed to be outlined. That was opposite because I mean it just generates pattern like code.
Correct.
Right. And then it can match the state A to state B wrongly, right?
Correct. Yeah.
So those kind of things I had to fix. Now, I mean, if I had written that whole thing by hand, like thinking it through and written by hand, it would have taken me an hour or two, and it took me like 6-7 minutes to do the whole thing.
Correct.
Out of that 6-7 minutes, like I think 1 minute was generating the code and probably 5 minutes fixing all of these things.
Yeah.
But it takes me 5 minutes because I've written a lot of the code of that type. And if I was new, I think it might have taken me 2 hours anyway to fix all of that stuff again.
Yeah. No, you're right. So I think one thing we have to realize is that we're still very early in this curve.
Yeah.
Right. We might not be very early in software development, but we are very early in the curve where
trying to fit LLM
most of the code is being dished out to us, and we have to fix that. Right. That's one reason why when I had applied for this beta access for Devin, right. And I actually wanted to try it out just for the reasons that you said, because ChatGPT or anybody or Claude were basically spitting out code without thinking, there is a tomorrow, right? That's not a code that we actually work with, right? You have to structure it in a certain manner. There are ways in which you can create it, design your APIs, and low-level design of the code has to be adhered to and whatnot. When I tried out Devin, to me it struck that, that problem is actually a solvable problem again. Right? It's not like that part is the rocket science. So what I did was I actually gave Devin a problem which I had no idea how to attempt. Right? I said, the only thing that I know is basics of software engineering. Now let me see, can I work with Devin? So I asked Devin, hey, can you actually create a RAG model? Right? Which basically for a customer service bot. Right? Let's do that. Right? It's a high-level problem statement. And then it said, okay, I will need this data. So I said, okay, I will give you the data from, let's say, HackerEarth public documentation. I have the API documentation. I have the product document. I'll give it to you. Now you create an agent or a support agent using a RAG model. One thing, obviously, it was actually, at the end it failed. It could not build the entire thing. But one thing that it was very beautifully able to attempt or sort of get to is how to sort of break it down to different pieces of the software itself.
Fair,
Right. So it's like, okay, if you are giving me a web link to go through the documentation, I will write a separate scraper. Right. If you are giving me a PDF, I will do it in this way. Right. So it's actually creating, what we would typically end up doing as user stories. Right. So it creates a project plan of sorts. It creates a different list of stories, and then one by one, it is basically checking them off. So the execution breakup of this entire problem, which is like a 2-line statement, is a very, very neat and I feel a solvable problem.
Right.
Now, again, it may not be able to functionally achieve all of those user stories very well, but I think to some extent it is able to attempt that. So I think we will get there. How soon? I don't know, but I think we will get there, and that's the real sort of worry that I have, and that's why I'm a bit skeptical about the whole opportunity landscape a little bit, because so far we've heard about software eating the world. This is like software eating software.
Yeah.
Right. So this is like software, because now you were doing these bits and pieces. Now if I was writing a web scraper, or I was using a scraping library, somebody wrote it, but still that somebody wrote it. Right. Now it's like this thing is basically spitting out that scraper code in like milliseconds. Right. So obviously it has an impact. Right. Now, how big is the economic impact of it? That's where I think it kind of balances out, because net, what you said, right? If it would have taken you few hours to kind of do that Flutter app, now it's taken you 15-20 minutes.
Yeah.
So you saved on the economic output that you can create in the next few hours.
Of
right?
course, yeah.
And that adds to the net sort of GDP, if you may. Right?
Yeah, fair enough. I mean,
and that kind of plows back into the same thing.
I love it because it saves time, and the time it saves, I get to do probably other things. Yeah.
So the affordability aspect of being able to write software kind of becomes, goes too low, right? I mean, and everybody can afford software. So tomorrow, we should not be surprised if very, very manually intensive, ops intensive folks end up using more software, because it's just become cheaper to produce software. Correct. Right? Economically speaking. And because it happens that way, there will be a need for folks who actually understand how this thing is working. So net kind of balances out, but the way things are being built, that changes.
Right. I think that makes sense. And sort of combining like this with obviously your field of work again. The question obviously is that how will assessments also change for post Gen AI world for assessing people. Like, I mean, for example, the DSA kind of way of evaluating, right? Yeah. I mean, it evaluates, I think, and correct me if I'm wrong, but I think it evaluates two things. One is like obviously being able to translate subjectively written out problem into like a logical solution of it, and then sort of think in bits bytes booleans as well, right? And then the second thing it does evaluate is that that thought process, are you able to actually write into computer ingestible stuff or not, right? Another thing is that the first part is definitely important and will remain important. It's like I mean, that's not really a computer science problem in that sense. Like, people who are good at it can solve other problems also very well. Fair enough. But right, if you're able to sort of come to a logical answer to the problem, which is like somebody says it in English and you can turn it into Boolean algebra. From there till writing the code, that part I think humans might be doing less and less of that going ahead, because something like GenAI can do some of it is what we are hypothesizing right here. Correct. I kind of agree with that as well. So then, like, how does that evaluation change? Because the evaluation is short-circuiting step A and B together, and you're looking at the output of step B. But if you evaluate if there is a way to evaluate somebody on step A itself, that is also pretty great. And step A to B is something that GenAI can be doing. So how does way you assess change? I'm also asking this because I'll tell you a story, which is like, I mean, I these days, when taking some interviews, I sometimes take it using Replit, and then they have that they allow you to open the AI thing, just like Copilot, right? So I usually ask questions like, say I've given a URL. There's a bunch of images in that URL. You download that. you have to compress all of those images and then you put it into a zip file, and then there's this drive link where you have to upload it. So you have to write this code. And this is something that you can write in half an hour.
Correct.
I just want to be able to see that, oh, there are 500 images. Can somebody think of compressing them parallelly rather than doing it in a for loop or something like that? Can they whatever language they're writing, and this is a question that works in any language, right? So can they think of like doing those IO calls asynchronously properly or not? Are they able to close the network connections and all of that stuff? Right? And it's just a very quick ragtag question to check that rubber meets the road kind of code they can write. And it's like, I'm usually taking third round of interview, somebody is already assessed where they're right basic code and all, right? This kind of code, and like you can write using whatever Node.js, Python, whatever Java you're comfortable with. And because it's a Replit, I tell them that it's just letting the AI bot is enabled. You can keep it enabled if you want to. You can disable it if you want to. Completely up to you. And I usually let people Google during this question as well. So it's like you open it on shared Replit, and you can share your screen. You can show me what you're Googling, but you can Google anything. You can open any website.
Correct.
All that. So one thing I've started seeing is sometimes some people who are not yet really adopting to the GenAI thing very much. They're not tried out a lot of Copilot and all. They start getting confused because the AI output keeps coming, because that's very different from their traditional autocomplete, right? I mean, it is not completing just the variable name.
Yeah.
And because sometimes it completes what you want, but sometimes it completes something very
else.
much opposite from what you want. And then it gets like confusing for people. And then like, okay, how can I turn off the AI? So that three kind of things which I see happen. One is like people who actually turn it off because it gets confusing for them.
Right.
And the second kind of people who very eagerly take up some of those suggestions, and then they get stuck trying to fix it because they've taken up a whole, they take a 500 function autocomplete, they take it up, and then they try to run it and it does not run, and then they have to debug 500 lines of code that they have not written. Right? So they turn their whole interview into a debugging session of debugging GPT's code.
Right.
And then there's a third kind of people who actually are very smooth sailing people who have been using it. I understand that they're using the AI kind of tool a lot. So they usually write a comment before writing the function, because that improves the prompt, right? If you write a comment and then you start writing the function, the autocomplete is usually much better than if you just start writing the function. So they do all of those steps. They usually break out the functions first and then they try to write it. So it's like, oh, this person is sort of like a prompt engineering is a good prompt.
So I was actually coming to that, but I'll let you complete it.
So that's what I was saying. So I mean, I've started to let people use the AI auto prompt if they want to. Like you can turn it off, you can turn it on, completely up to, because I allow Google, so I allow this as well. I mean, my question was like, how do you see kind of how we assess people's ability to build software, I would say, in the post-AI world? I would not say like write code, because maybe if the write code step goes away, who knows? So like, how do we evaluate software engineering abilities in the post-AI world?
Two things that we've kind of already taken up as part of the product, right? The first thing that we did was actually incorporate a ChatGPT integration within the candidate interface. So you can actually, as of today, on HackerEarth, go to ChatGPT, ask, whatever prompt, give it whatever prompt, get the code. Obviously, that's a choice that first the organization has to make, whether to give this to the candidate or not, right? Surprisingly, a lot of organizations are still not okay with it. I don't know why, but they're not, right? It doesn't make sense, right? Because it's not like, in real life, you're going to stop them from, in fact, you'll probably force them to use something like this because it saves time.
We paid for
Copilot. Business everybody's doing that.
And now I'm looking at the stats, and wherever I see people are not using, I'm asking them, we are paid for you, why you're not wasting.
Correct. So that's one thing that we did. I think within the first month or so of this integration becoming public, we did that, right? The second thing that we did was we created a whole bunch of questions where we said, hey, this is the problem statement, very similar to the debugging problem. But here what we did was we created a DS algo kind of a problem statement and said, we've given this to ChatGPT, here is the output. right? Now go ahead and figure it out,
Right,
like
right, right.
whether it works. Sometimes it may work 99%, sometimes it may work like 50%, right? And ultimately you have to pass like whatever 20, 25 test cases. So you have to figure it out. So that solves for the folks that you were talking about in the middle tier, where they generate a whole bunch of code, but they're not able to fix it.
Yeah.
So that's one. I think the third part where the folks are sort of able to work with this very efficiently, obviously they are the ones who've actually been using it, right?
Yeah.
Actively. That's where I think, if you go, I think it's almost been 1 year when there was this big headline that there's a prompt engineering role and the engineer is being paid 300K, 400K, whatever, some such thing, right? And look, prompt engineering as a full time, I don't think it's a role,
Yeah, I
right?
mean,
It's not a role.
every role, the top 1 percentile people would be
Yeah,
prompt engineers in addition to whatever they're
whatever they
doing.
do, right? There's a
Graphics
core,
designers also and coders
right?
also. Yeah.
Right. Any type of content that you are generating, whether it is code, text, images, whatever, you will end up using
If
some
you're
sort
good
of.
at prompting, then
Yeah,
whatever you do, you'll do better.
correct. So it's not like prompt engineering is like a full time role on
But
its
that's
own.
same like any profession, right? I mean, if
Yeah.
any
It's a
engineer, like
tool.
if you're good
It's
at conversation,
right.
you grow more in your career. If you're bad at conversation, you don't grow. It's like
Absolutely.
one of those things. Yeah?
Absolutely. So the thing is, now how important is that skill, right? And I think that's where organizations have to take the lead and be more open to sort of giving first access to the employees themselves, and then also be open to kind of testing out candidates while they are
Like you were
hiring.
saying, I mean, we can't stop it from happening.
Yeah,
It's
yeah.
happening. So
Resistance is futile. There's no point. So there has to be certain amount of a builder mindset that this checks, right? Where you're like, I have to not just in terms of the product or a feature, but also in terms of the code. Like, how do I build put together this code, right? So like we were discussing, there's a scraper, and then there is a code that will basically encode this or encrypt this or hash this or whatever, right? So you have to organize this, right? And how do you organize this while using something like chat gpt or claude or anthropic, whatever it is? I think that's just a way of solving problem. And I think if the organizations start taking lead, I think we are as HackerEarth, at least we are more than open to kind of trying these things out. That's why we took the lead and said, you have this available, go ahead, use it. However, but that's very plain vanilla integration. That's like give a prompt, whatever prompt, and basically solve the problem. But I think there'll very soon be organizations who will say, no, let's actually monitor and evaluate the prompts as well, right? And see how fast are they able to do the work with the prompts and without the prompt, or rather with the LLMs and without the LLMs, right? I think somewhere that benchmarking also will come in. That's probably the next step.
Makes sense. So yeah, I mean, thanks for answering all of these questions about like how the Gen AI, is sort of impacting, and because you also are having a ringside view to it. One final question that I have which is probably more directed towards young developers who are starting out their careers, and a lot of them are part of the HackerEarth community as well, and I'm sure you get to interact with a lot of them. So yeah, I mean, I think there have been two major sort of shifts which have happened in the last few years, which is like the word post-ZERP era, which people have been calling, like obviously like the way tech companies were growing, and now how they are evaluating and how they're hiring, some sort of jobs and all going away. And then the other part is this, sort of AI being able to generate a lot of content. So I say these are two different things because I mean I feel they are. I mean they have happened at the same time, and a lot of people try to conflict, but I think they're two very different kinds of shifts, but they're happening together, sort of, right? So yeah, I mean in this sort of the environment, people who are sort of starting their careers in tech, especially like people who are starting out writing code, software engineering, any sort of last words from you and advice?
No, I think, see, these days, when I talk to young engineers, I don't generally have to give them advice around what is the skill set that they require for a job, because they are more often than not, they are very, very well equipped with that information. But if I had to, anyway, add two bits, I would just say that, I think it's far more easier to add value these days. So instead of maybe solving a DP problem, or solving, let's say, some other greedy algorithm and whatnot, try and go a step beyond and actually pick up some real life problems and solve them, right? I think that will help you not just probably get some experience with these tools that are available at our disposal today. But also I think it helps you build a builder mindset, right? Which is solving problems at a slightly higher abstraction than just writing DS algo. So I think that's definitely a directional advice that I can give to a lot of youngsters, because I do, and that also honestly is happening, right? It's not like I'm talking about anything new. It's just that folks who are not very aware, like, tier 1 colleges, you don't necessarily have to tell them anything. Even tier 2, they're very, very well informed. It's probably folks tier 3 and below, where they are probably not exposed to as much what is happening on the tech word side. So I think there we can definitely, and organizations like Scaler and all can also come in and sort of help. And we try and sort of do this through our community engagements, that educating them on how to operate at a slightly more higher abstraction level, and creating more problem solvers rather than just coders, pure play coders. Of course, doesn't take away from the fact that you have to understand the basics, but trying to solve problems and real world problems and business problems, I think that also helps folks who have an entrepreneurial mindset, right? Because I think now that one member startup or a two people startup is a lot more feasible than it was probably 10 years back.
Yeah.
Right. So I think, that would be the only advice.
Cool. So yeah, once again, thanks for answering all of the questions. It was like a great session chatting with you. Lots of great answers, and lovely knowing about your journey as well. Like all the time at Amazon, it was like a great set of things to learn. Thanks again for taking out your time.
Thank you so much, Arnav. Nice meeting you.
Yeah.
And we should connect again.
Sure.
Thank you.